Welcome to this video, and in this particular video we are going to talk about Kafka. So yes, this is a complete course on Apache Kafka, wherein we are going to begin with the Kafka introduction. We are going to take a look at what Kafka is, why you should make use of Kafka, the problem it solves, and all of that. So that is something that we are going to discuss. And then we are going to go hands-on with Kafka, wherein we are going to set up Kafka with our Spring Boot application. And we are going to take a look at different things like how can you set up a Kafka topic, how can you send messages or any sort of data to a Kafka topic, and how can you set up a producer and a consumer that is going to produce messages and consume them. We're also going to understand the concepts of partitions, consumer groups, all of this in a hands-on way. So we are going to take a look at different concepts, and we're going to understand it conceptually as well as in a hands-on way, right? Then we are going to start transitioning towards Spring Cloud Streams. And for using Spring Cloud Streams, it's important that you make use of or understand what Spring Cloud functions are. And for making use of Spring Cloud functions, it's important that you understand what Java functions are. So I give you a brush up of what Java functions are and why they exist and what are the different Java functions that exist. Okay. Then we talk about Spring Cloud functions, wherein we understand what they are, how you can make use of it. And then we start transitioning our project to Spring Cloud Streams. And then we configure Kafka to work with Spring Cloud Streams. Okay. So you understand the difference between two kinds of setups with Kafka. One is with Spring Cloud Streams and one is without. So throughout the course, we have a project that we'll work on, and we'll set up that project and get it working with Apache Kafka, and we'll understand different concepts of Kafka. And then we'll transition that same project to that of Spring Cloud Streams. So for the same project, you will have two perspectives or two ways of using it with Kafka, and you will be clear as to which way you should use when and how can you use it. Okay. So yeah, that's the entire goal of this particular course. Now, goes without saying, my lectures are always hands-on. That's the benefit you get. I make use of slides, but very minimal. And I use slides only when needed, and if there is something that cannot be explained with the help of ID. So that is when I transition to slides for better experience of students. Okay. Explanations are really simple and to the point, so you won't have any problem understanding things. Okay. So that's a promise I bring this course to you all with. This course is absolutely free, and you all can leverage learning Kafka from here. And if you are finding this content valuable, and if you found this helpful even by a bit, okay, I would love to ask you for your support. You should subscribe the channel, turn on bell notifications, and also hit the like button. Also, I would like to learn more about who you are, where you're joining in from. So feel free to drop in a comment below. Okay. I would love to know like who you are, where you're joining in from, what sort of videos I should bring on the channel. I'll read each and every comment. I may not reply, but I'm reading each and every comment. Okay. So yeah, feel free to drop in the comment and show some love on the subscribe and like buttons. Okay. So without further ado, let's jump right in. One small thing before we move forward, I want to give you an overview of my course, another course that exists. Okay. And if you're finding this content valuable, you will definitely love to check out this particular course. This is a Spring Boot microservices course wherein we build an e-commerce application using microservices architecture. Okay. And it's a 55-hour course currently as I'm recording this video, and I'll be adding more number of hours into this particular course for sure. So people who have enrolled into my courses or who take my courses regularly, they know that I keep adding content. Okay. Now, what is different in this course and why you should take this course? So first of all, I'll tell you, this course sells on Udemy. This course is hosted on Udemy. So if you click on the enroll button over here, you will be taken to udemy.com with the lowest price possible at that point in time. Okay. Now I don't control the pricing over here. Udemy controls the pricing, and Udemy sells this course. So there are two ways to get this course. One is you pay a certain amount and get a lifetime access. Another way, this course is part of Udemy for Business catalog. So you can see over here, it's part of Udemy for Business catalog. And if you have your company's Udemy for account, Udemy for Business account or subscription access with you, then you can enroll in this course for absolutely free. You don't have to pay anything. Okay, so that's the course over here. You can see over here right now it's 56.5 hours as we are filming this video. If you scroll down, you'll see first we begin with the monolithic application. So here in the first part of the course, for around 5-6 hours, I cover how you can build an e-commerce application in the monolith architecture. And then what we do is we transition. So here you can see microservices section starts. We begin talking about different databases. We restructure our application. So this is where we start restructuring our application into microservices, and we convert a monolithic application to that of microservices. So I start splitting services, and this gives you a good understanding of today. If you have your company, if you're working somewhere, okay, and if you have a monolith application and you are not able to scale, so your boss might ask you like, hey, let's switch to microservices architecture, and you have the knowledge over here as to how you can transition from monolith to microservice. So that is important. Okay, I teach you different databases. So in microservices architecture, you get the liberty of making use of different databases. So MongoDB, MySQL, PostgreSQL. I show you everything hands-on way, step by step. Okay, we talk about configuration management. Now, there are a lot of things taught in this course, okay, that are not taught anywhere else. For example, this section on configuration management is just 5.5 hours. It's a course in itself. It's a separate course in itself. So I teach you a lot of stuff. You can see over here, different ways of managing configuration, how you can host your configuration on GitHub, how you can host your configuration in a private GitHub repository. All of that is taught over here. Okay, you can see everything. Okay, it's totally in depth, no fluff. I teach to the point, but still it's 5.5 hours. Okay, I could not reduce, but that's okay. We are learning production grade techniques, and you can implement a particular way of managing configuration depending on your project. So I teach you all of that. Then inter-service communication, it's totally in depth. You can see service discovery, totally in depth. We make use of different REST clients that are available. These are modern REST clients that exist. So I teach you all of that. Then I have observability section, which goes on for almost 4 hours. Okay, and I teach you how you can implement observability using Grafana. So we make use of Grafana, and I teach you how you can monitor logs, metrics, and tracing using Grafana. Okay, and we also cover Zipkin. So that's something we have. API gateway. So we talk about API gateway, how you can make use of Spring Cloud API gateway. Then we have, so we have fault tolerance as well. And there are a lot of sections coming in. And then we have another project over here, which is a job application. So here we have a Docker Kubernetes also covered. Okay, so this is a complete package with a future roadmap. So if you come over here on the website and you check this roadmap, this is a roadmap as to how I am going to update this particular course. So there's a lot coming. Front end is coming in. You have a deployment section. You have security deep dive. Now, security is not like I cover just one thing. I'll show you different scenarios in which security can be implemented. You'll be learning production grade techniques. That's the difference. Okay. So it's very in depth for serious learners, and it sells on Udemy. So I don't need to tell you the price point at which Udemy sells courses. Udemy sells courses which are very affordable. I could have hosted it on my own platform, but I believe in affordable education, and that's the reason why I have it hosted on Udemy. Okay, so just to give you a gist of the price in India that it sells at is below 500. So you will easily get it for below 500 INR. Okay, in India. That's really cheap, I feel, compared to the value that this course delivers. And outside India, you will get it below $15. So sometimes the price is $12, sometimes it's $13, $14, but below $15. Okay, and that's the value. Okay, and it's very highly rated. You can see. Now this is microservices. We are making use of microservices architecture to build an e-commerce application. I have one more course. Okay, which is this one. I have it open in the tab. This is again hosted. You can see this is the landing page, and it's hosted on Udemy. Okay. Now this course, what is difference? What is difference in this course and this course? So this course also we are building e-commerce application, but we are learning Spring Boot while building e-commerce application. This is on this other course that I just spoke about, this is microservices architecture. So I assume that you know a lot of Spring Boot. I touch upon Spring Boot, but I don't go into depth because that's not the motto of the course. Okay, if you're learning microservices, you should be aware of Spring Boot. But yes, we do brush up some concepts. I teach you how APIs work and all. Little bit of brush up we do, but in this course, that is the other course, here we are building a production grade e-commerce application using Spring Boot monolithic architecture along with a production grade technique used, and we are building React front end as well. Okay, so this is very much in depth if you are looking to learn Spring Boot and build a portfolio project for yourself. Like the e-commerce application we build is very much complex. We handle a lot of complexity. So you can see over here, like cart management, order management. There is payment integration using Stripe as well, validation, sorting, searching, all of this, deployments, and it's 85 hours long. Okay, so if you click on this and if you go over here, you'll see like it's the category bestseller right now. Okay, a lot of people have found value with this course. It's 4.6, 4.7 star rated and almost 90 hours, 89.9 hours. So it's very much in depth. I would encourage you to check out this course. So if you don't know front end, it also teaches front end. You can see over here. So first we talk about a Spring Framework. It starts with Spring Framework. Then we talk about GPA and Spring Boot. Then we talk about advanced things like security, managing user profiles, custom authentication, how you can customize security. That's really important. Okay. How you can manage shopping carts, different databases, manage user addresses, orders and payments, all of this, Stripe integration. We do all of this. We deploy the application. When we deploy the backend, and then we switch about front end. We switch talking about front end. So I teach React first. I don't directly jump to front end. So we learn React and I have tagged lessons like React Beginner, React Intermediate, React Advanced. So depending on your level, you can pick the sections, and then we start building the front end as well. And we make use of complex topics in React like Redux. So all of that is covered as to how you can manage front end and how you can, improve on it. Then you have some AI related applications. I have some few projects in the end as well, how you can deploy your application for free. So these are some useful sections that exist. Okay. And then the course has the job application. So this is the older version of the course, which students requested me to have. Okay. But the course is really comprehensive. It's totally in depth and totally worth it is what I would say. Okay. And yes, you can also take a look at the live application demo or check out the preview videos over here on the landing page itself. Okay. It should have the application demo. So this is something, so this is the difference between two courses that I just told you. One is using microservices architecture. One is using monoliths. But yes, we cover a lot of features of Spring Boot. So if you are learning Spring Boot, or even if you are an advanced level developer, you will still get value from this course. Okay. There are a lot of things that are covered which are not taught everywhere. Okay. And it's all based on my personal experience. So that's something that I'm sharing over here. And you can take a look at this, and you can find a lot more over here on embarks.com. Okay, so this is the course that I was talking about. This is the microservices course. I have Spring Security course. So there is a Java programming course as well. And there are tons of courses that exist. So you can just explore this website. Okay, I'll leave links to these courses that we spoke about. Okay, and you can basically go through everything in the description below. Okay. But I would like to tell you, like, these courses are not expensive. Okay. Trust me, if you build something valuable in your portfolio, you get a job. Okay. You might, if you're a fresher, you might land your first job. If you're experienced developer, you might get a better job. So it's not like I'm experienced and I don't need to create my own portfolio of applications. I truly believe if you are a developer, you should have portfolio projects. You should have portfolio up there. And you should showcase that this is what I've built personally. Yes, this is my experience. I built this for the company. But apart from learning and working for the company, I have my own personal projects using Spring Boot. That adds a lot. That adds a lot, So this differentiates you from the other people who are interviewing for the same job. Okay, because you You also have your personal projects. Yes, you're working for the company. You're also building your personal projects. So that is what distinguishes you from others. So that's something that I'll tell you. Keep building projects, and I would tell you, learn publicly. You should post on LinkedIn that, hey, I'm following this. I'm building this. I built this application. Deploy it. I cover how you can deploy for free, including front end, back end, and database. You can deploy your application for free. So that is valuable, and these courses like these help you do that, and the job you get pay you a lot more than you spent on these courses. So you are hardly spending anything, so $500 in India and $15 abroad, like outside India, is not a lot compared to the value it delivers. So that is something that I'm saying, and it's a fact. You can go check out the reviews of my courses as well. Okay, so enough of this. I think we should move on to next. I hope you have got the point over here. All right. It's time that we understand what Apache Kafka is. So what is Apache Kafka? Apache Kafka is an open source distributed event streaming platform. Now, there are few keywords that you should make a note of, or few details that you should make a note of in this definition. First is open source, then it's distributed, and then it's an event streaming platform. Open source meaning it's open source, like it's freely available to use. And distributed means it can run in a distributed environment. We'll understand how this works as well. Event streaming, we'll understand the concept of event streaming as well. Okay, so these three things is something that you should remember. Let's talk about event streaming, what event streaming is. So event streaming is a way of producing and consuming data. Okay, and to understand this, let us have an example. Let's say you go into a coffee shop. Okay, now in a coffee shop, you will have a cashier who will take your order. So here we have a cashier. This is you. You go to a coffee shop. Cashier takes your order. Now what would happen is cashier, let's say you order a cappuccino, a coffee, right? Now that's an event. Okay. You ordering a coffee is an event, right? Now your event or something that you have produced, you have requested for coffee. Now based on that, a lot of things would happen in the hindsight. Okay. So once the order is placed, cashier will go and talk to chef that, hey, there is one cappuccino ready. There is one cappuccino that is requested by one customer. Manager will be notified so that he can make a log of this particular order. Like cashier will also inform the waiter so that he can go and give you the coffee. Okay, and you're waiting inside the restaurant. You have taken a table after placing the order with the cashier. Okay, this is just a hypothetical example. Now imagine if there are tens and hundreds of orders coming in. There is a lot of rush in the restaurant. Is this way of doing things scalable? Like cashier would be just running here and there. So he will be taking the order, he'll be running there, he'll be running to the manager, he'll be running to the waiter, right? And this model is not scalable, right? So after the event is happening, there is no one listening to this event. Instead, the cashier has to go and tell everyone that, hey, this order has come in and please make sure that this order is received by the customer. Okay. Now let us think of something else. Like let us change this model to make this a little bit better. Now let's say there is an introduction of a digital board over here in the restaurant. Now what happens is once you place the order on the counter where the cashier is sitting, the cashier, instead of going and telling to the individual people, the cashier just pushes this order to a digital display board over here in the restaurant. Now digital display board is something that everyone is keeping an eye on, right? Chef is watching this digital display board, manager is also watching this, and waiter is also watching this for all the orders that are coming in. Okay, so you get a unique token number. Let's say token number 1, yours is the first order. The digital display board will say 1 cappuccino and the customer name and the table number, for example, right? So chef would know, okay, there is 1 cappuccino I need to have for a customer. Manager will make a note of this, and also waiter will make a note of this so that he can come and serve you, right? So here cashier is not running here and there. Instead, he's pushing the order to a digital display or a digital order board, you can say. And based on this, like whatever is being displayed in this order board everyone is seeing and keeping an eye on this order board, right? And everyone is basically listening to this order board is what I can say, right? And based on this, like the entire restaurant runs, and the life of cashier is much more better, and this model is very much scalable. The cashier sitting on the counter does not have to run here and there to make sure that your order has been delivered, right? So this is the problem that Kafka solves. Okay, so Kafka, you can think of this digital display board. I'm just sharing this analogy. Kafka can be this digital display board, and you push in an event to Kafka. There will be a lot of services that are listening. Those services are known as consumers, and the one who has produced the event, that is you, will be the producer. So I hope this analogy is making sense as to how Kafka comes into picture and solves the problem. Okay, so first of all, one benefit over here is there is no direct communication between the cashier and every staff of the restaurant. Is there any direct communication? No. Cashier just does the job of pushing the order to this digital order board, right? Now anyone can join or leave without disrupting others. So if manager wants to leave, he can leave and some other manager can replace him and keep watching this digital display board. A chef can be replaced, waiter can be replaced. Okay, but in the older model wherein we had cashier going manually and telling everyone, if anyone is replaced, there can be a communication gap, right? But here there is no communication gap. Everything is displayed on this digital order board and everyone is following that, right? And everyone works in real time, okay? And everyone works in a asynchronous manner. For example, if a order is pushed to digital order board, cashier can, manager and chef can take their time to make a note of the order and start working on it. Of course, they can't be too delayed because then the customer would go away. But yes, they can take a lag of like 5 minutes and then they can take a look at the order like for the next set of orders and they can start working on it, right? So it's completely asynchronous as well. Now this is how Kafka comes into play, and it helps improve your entire application. Okay, so how does Kafka help? Kafka helps by decoupling services. It makes services much more scalable. So when I say decoupling, meaning there is no tight dependency. So over here in this diagram, you will notice that there is no tight dependency between the cashier, you, and all the players in the restaurant, right? And if you have Kafka in between, things are much more decoupled, right? And services become much more scalable. So tomorrow, if you have 10 chefs over here, they are given the same protocol, same rules that they have to keep listening to this digital order board, right? There is a ability of going back to the previous orders as well over here as to what order came at what time, because you have this being digitally recorded as well. So you can go back and see yesterday's orders, and there is much more efficiency. Is what I mean to say, right? So Kafka exactly does this. It helps us decouple the services. It brings in scalability into your application. There is an ability of replayability. So basically what I mean by this is even missed events can be processed later and you can go back and check the previous events as well. And there is a sense of efficiency over here because there can be one connection per service to Kafka and not many to many. Okay, so that's what this is how Kafka solves the problem. And now talking about event streaming. Okay, so coming to event streaming means continuously capturing events data in real time, okay, and storing them in a log like a timeline, and then allowing systems to react to them either immediately or later. So this is what event streaming is. So you are continuously sending events, and that is what is known as event streaming. And what happens is when you are continuously sending events in real time, those events are stored in log like a timeline, and then other systems who want to check these events or who are subscribed or who are listening to these events come and react to them either immediately or they can take their own time and react later. Okay, for example, in our restaurant analogy over here, orders coming in is an event. So now you have placed an order, there will be hundreds of other customers who will come in and place the orders. Now this cashier who is sitting on the counter will do the job of pushing the order to the digital display board. Chef will immediately react to these events and he'll start preparing the orders, right? Manager can take his time, like he can make a log of the orders that are incoming, like what all items are going in, how the restaurant is doing. He can take his own time because him reacting to these events is not immediate. Like his reaction is not needed on an immediate basis. Chef's reaction is needed on an immediate basis so that the orders are not delayed. And waiter can also take his time because once the order is ready, only then he has to come into play and he has to make sure that he serves the order, right? So everything is working by their own time, right? So here, if you see, events are coming in, which means like the orders are coming in continuously, and in real time they are being stored somewhere. Like we have the digital order board, and then other systems like chef, manager, waiter, you might even have an accountant. So they will do the job of reacting to them either immediately or later. So that is what event streaming is, right? Now if you convert this example into tech terms, you will have something called as a producer. Now who is a producer? Producer is someone who sends in the event. So in our example, you were sending in the order, the cashier was creating the order. So they are the producers, right? So producer will create an event. Kafka will store the event, okay? And generally the events are stored in Kafka topic. Now what are topics? We'll come to that. But events are stored in Kafka, and then there are multiple other services. Like there can be one or multiple, depends on your architecture. But there can be services who are listening to these events and they are processing it, and they are known as consumers. So here we have a couple of consumers in the diagram. There can be hundreds of consumers. Just telling you this, okay? It's not like you have two consumers or only one producers. There can be hundreds of producers, hundreds of consumers, and then if there is a lot of load, lots of events are coming in, then you can even have multiple instances of Kafka running together in a cluster, right? That is something that you can do, and that is what distributed environment is, right? So this is how things translate to the tech term. You can have a service, for example, an order service. Once the order is placed, the order details are sent to Kafka. Then you can have a notification service that will listen to Kafka for sending in the notifications. You can have a SMS service that can listen to Kafka and send in the SMS. You can have invoice service that will generate the invoices for all the orders that are getting placed. So they will act based on their own timeline, okay? And depending on the kind of events that are coming in, they will do the processing further. Now, event streaming is a way, as you can imagine, it's a way to pass in data, right? You're continuously passing in or sending in the events in a stream. That is what event streaming is, okay? Now, is event streaming just the only way to pass data? Not really. There are other ways as well, and I have a table explaining different ways of passing in data. So you can see over here, we have one way. We'll talk about method, the description, and an example, okay? So method is request response. So request response is one way wherein you can send in and pass data between two systems, okay? So one system will call another and wait for a reply. That is what a request response way is, right? And an example of this is REST API or using HTTP protocol, right? So this is what request response is. If you have built APIs ever in your career, you will know what I'm talking about. Batch processing. Now what is batch processing? Batch processing is a way wherein system processes large chunks of data at intervals, okay? And an example of this is basically nightly data imports that are happening, and also reports generation that you might do. So there batch processing comes into picture, wherein you are taking large chunk of data and processing it together, okay? Then you have something called as message queues, wherein one system will send a message to another queue, or it send a message to a queue, and another system will pulls data from it. So that is the concept of message queue. And there are examples of message queues, like RabbitMQ is one popular one, okay? Then you have event streaming. So event streaming meaning system will send and react to a constant flow of events, right? And if you're building, let's say, analytics system, so there are like millions of customers who are using your application daily. In that case, your system will send in continuous stream of events because there are so many users coming in every second, right? So the data that is being generated is a continuous stream, and that is what event streaming is. And normally to handle such kind of load, Kafka is being used. Kafka is quite popular out there, okay? So these are different ways in which event streaming can occur, and not different ways in which event streaming can occur. These are different ways in which data can be passed in, okay? So I hope this is making sense, and I hope you are able to follow along so far. Now, what is Kafka? So you can think of Kafka like a WhatsApp group. Okay. So I'm just giving this analogy over here so that you can understand Kafka better. Okay. So you can think of a WhatsApp group. Now what happens in a WhatsApp group? There are people who sends in messages. Okay. There is a group chat itself, right? So people are sending messages where? Within a group chat. Okay. And then there are people who are reading those messages, right? So people who are sending the messages in the group, they are producers. Okay. The group chat that you have is a Kafka topic. So normally the messages and events that are going to Kafka go in topic, right? So group over here is a topic. You might have thousands of group, or not thousands, okay? You might have tens and 20s and 50s and hundreds of group depending on like the kind of chatting you do, okay? But you might have more than one group in WhatsApp, right? And every group is a topic basically. So likewise in Kafka also you have something called as topics, wherein you can send the message. For example, if you have a school group and you have a college group, now you're not going to send some messages that you intend to send in the college group in your school group, right? You'll send it in college group only, right? So that way the concept of topic exists in Kafka, wherein, you know, if you're sending in order related messages, you will send those message in order topic. If you want to send in notification related messages, you will send in notification topic. Okay. So that is Kafka topic. And then you have consumers, like there will be people to whom the message will be broadcast. And these are the people who have been added into the group. Okay. And they will consume and read those messages. Okay. Now, what is the coolest part over here? Okay. Let's think of coolest part. You understood this analogy. Kafka is like a WhatsApp group. Okay. Now, the coolest part over here is even if a group member offline, what happens? So if you're online, you get the message. If you're offline, what happens? Do you miss the message? Not really. Okay. What happens is when you come online, you get the message. Okay. Likewise, in Kafka, if there are 10 consumers listening to a topic, and let's say 3 of them are offline, some maintenance work is going on or there's some network issue. So in that case, that message is not lost. When those services are up, they can start consuming the messages from where they have left, right? So like when you open WhatsApp group, you will start reading the messages from where you have unread messages, right? It will show you the list of unread messages. These many messages are unread. So you can go and read from there. So likewise, you have concept of offset from where you can go and read the unread messages, okay? Now, when you come online, you read, okay, so none of the messages are lost and messages are also stored in order. So you always see the correct conversation flow, right? And multiple people can also read the same message, like in WhatsApp chat, like multiple people can read the same message, right? And there is a concept of having multiple consumers where multiple consumers can consume the same message. Okay, so that's what Kafka is when you compare it with the WhatsApp group. I'm trying to make things simpler by giving you these analogies, and I hope this is helpful and making things clear for you all. Okay, now let us do a small comparison with that of RabbitMQ. Okay, so we'll do some comparison based on the features, and we'll see how they both compare and stand against each other. So first thing is the model on which these two operates. So Kafka operates on event streaming model, which is log based model. Okay, and RabbitMQ operates on the message queuing model. So there is a concept of message queues with RabbitMQ. Okay, then talking about message storage, so Kafka will keep all the messages for a set time. Okay, and you can read those messages. Okay, RabbitMQ will delete the message after it's consumed, so it won't store the message. Consumers. So each consumer now in Kafka, like there is a concept of consumer groups wherein you can group the consumers together. Okay, if you are not a part of the group, like there is a scenario wherein consumers are not part of the group. Okay, so they can read the message independently. But in RabbitMQ, messages are removed once delivered. Okay, now Kafka is best for high throughput, real time analytics data replay. Now, what do you mean by high throughput? So throughput is a rate, or throughput is the rate at which messages are processed. Okay, essentially it's a metric that tells you how much data the system can handle in a given period of time. So the throughput for Kafka is really, really high. It can process large number of data, large amount of data in a very short period of time. Okay, and it's normally used for tasks that require high throughput, meaning real-time analytics, data replay. So all those kind of use cases are best with Kafka. Okay, but RabbitMQ is good for task queuing and short-lived jobs. Okay, persistence. So Kafka is designed for long-term storage and replay, but RabbitMQ is for short-term delivery. This is something that we already saw. Okay, it deletes the messages. RabbitMQ. Ordering. So Kafka has the concept of partition. If you're not aware of partition, don't worry, we'll come to that. But just understand this for now, that within partition, Kafka guarantees order, like the order of messages. But for RabbitMQ, there is no strict ordering unless it's manually handled. Okay, and when we talk about throughput, like I said, Kafka has very high throughput and RabbitMQ has moderate level of throughput. I hope this is making sense to you all as to how Kafka and RabbitMQ stand against each other. So I hope you have a good clarity as to what Kafka is and what sort of problems it solves and what event streaming is. I hope you have understand this with the analogies that I've brought in. Okay, these analogies were just created to explain things in a better way. Okay, if you are able to relate to these analogies, things will be much more easier, and that is why I thought of bringing in these analogies. Okay, normally people don't understand or face difficulty in understanding Kafka because beginners, they find things really overwhelming. So it's important that I bring in these kind of analogies so that you understand things in a very simple way. I hope this has been useful and insightful for you all. So now it's time that we dive into Kafka architecture and its components. Now we are going to talk about a lot of stuff. Okay, I have these stuff or these things listed over here on the screen. So we'll be talking about events, producers, consumers, topics, partitions. We have a concept of consumer groups, offset, and consumer rebalancing. So let us go through each one of them. Okay, now first thing is, let's talk about events. Now what is an event? Now think of event as any meaningful action or message that is sent. Okay, for example, in WhatsApp, you have an event. If you send a message, that's an event. So let's say if I send an event in a group, I say dinner at 8, or if I send a message to someone, that's an event. Okay, so if you relate this to Kafka, an event could be like any event in your application. For example, order placed, payment done, user sign up, all of that. Now, event is just not the event itself, or event is just not the notification that this event has happened. Okay, it's also its data. So for example, if you have a producer, let's say there is an order service that is producing events, and let's say you've configured it with Kafka to send in the event data to Kafka. Okay, so order service will tell Kafka that, hey, one order has come in. If another order comes in, it will tell again like, hey, one more order has come in. All this thing will be logged in Kafka. Now, along with the event, its data should also be passed into Kafka. Like for example, any sort of important data that order service or the producer wants consumer to take action on. For example, order ID or payment ID, payment method, or anything, order amount. So all that data should be sent to Kafka as well, so that consumers who are processing that data can act upon it. Okay. So what is event? Event is something happened plus its data. This plus its data is really, really important. Now let's move on to the next concept, which is of a producer. Okay. So a producer is someone who produces the message, who produces the event. Okay. So in the context of WhatsApp, if you are sending in the message, you are the producer. Okay. If my friend Sarah is producing the message, she is the producer. Okay, and in Kafka, a producer is any app or service that sends data to Kafka. For example, if you have configured order service to send data to Kafka, it's a producer. If you've configured payment service to send data to Kafka, it's a producer. Now, one thing is there can be n number of producers. Okay, here in the diagram, I have only one producer showcased. It's not like you have only one producer in real. You can have 10 producers sending event data to Kafka. Okay, so producer is nothing but a sender. Okay, now what is a consumer? The consumer is the one who is consuming that particular event. Okay. So for example, if you have order service as the producer, you can have a notification service as a consumer. You can have SMS service as a consumer. You can have invoice service as a consumer. So for example, you can configure them like once the order comes in Kafka, notification service will start sending in the notification to the user who has placed. How will the notification service know who is the user who has placed the order and what to send? So it will take a look at the event data. So this is the order ID. The producer will send in event with all the data. Like this is the order ID, this is the email, this is the SMS, this is the order amount, and this is what he has placed. So notification service will take a look and it will trigger a notification. SMS service will trigger the order confirmation. Invoice service will generate an invoice and push it to the customer. So all of these things come into play, and these are all the consumers. So consumers are nothing but the listeners or receivers over here. I hope this is making sense. Okay. Now then we have the concept of topic. Now to explain topic, I'll just switch this and you can see some other diagram over here wherein I have elaborated the diagram of Kafka over here. So we have the producer who is producing the event. We have the consumer who is consuming the event. Okay. Now within Kafka, you have the concept of topics. Now, why do we have this concept of topics? Topics is nothing but it's like a channel for receiving messages. You can think of that. It's a way of segregating messages within Kafka. Because if you have 10 producers producing messages, for example, order service is also producing message, customer service is also producing message, there is a payment service that is also producing message. So all the messages will go in Kafka. There is no segregation. Okay, it's a chaos. So it's best that there is some sort of segregation so that it's easy for consumers to consume the data. Okay, because now we'll have consumer. So consumer will say, I'm notification service. I just want to read the order related messages. So what you can do is you can have a topic called order or order notification, something like that. Okay, and the producer, like the order service, can send the order related or order confirmation data to that particular topic, and then the notification service can just listen to that topic. It does not care about the other topics. Okay, so topic is like a named group or channel for messages. Okay, now imagine like if you have WhatsApp, you will have multiple groups, right, for multiple purposes. You will have multiple groups like family, work, friends, and based on the group name or based on the kind of people you have in the group, you will send in messages, right? So if you want to send some work related message, you will send it in work related groups, right? Similar way, if you want to send order related message, you should send it in order related topic. If you want to send some customer related message, you should have a separate topic for customer. So it's basically a segregation within Kafka, right? So you can have topics like order placed, user signed up, payments done, right? And if user signed up, there can be some consumers who are listening. If payment is done, there can be some other consumers who are listening to these kind of messages. So it's a segregation within Kafka. Okay. Now what happens is at times within topic, there are tons of messages. Okay. So this segregation within Kafka at topic level was done so that there is better bifurcation and understanding or better bifurcation of messages, right? But within topic, it can also happen that there are tons of messages. For example, if you're running a Black Friday sale, okay, and if you have order related topic, okay, and let's say there are 1 million orders that are being produced in a single day. Now this topic is going to be flooded with lots of messages, right, or lots of events. Okay, so within topics, you also have the concept of partitions. So you can have partition 0, partition 1. Okay, so they will do further segregation. Okay, they will do further segregation within topic itself. For example, if you have a topic, let's say, if you have this topic order, you can have sub partitions, like partitions within topics, so that different consumers can subscribe or listen to these partitions and then do the processing. Okay, now going further, you also have the concept of consumer groups. Okay, so what happens is if you have partitions, okay, if you have partitions, you would need a team of consumers also sharing the message load, right? For example, if 1 million orders have been received, okay, 1 million events will be sent to this particular topic in different partitions. So you should have a team of consumer who is consuming the messages quickly, right? So in that case, what you can do is you can have consumers that are grouped together. So these two consumers are grouped in a single group. You can name that group as well. Okay, so this is basically a team of consumers sharing a message load for that particular topic, and they are listening to individual partitions. So this is partition 0, this is partition 1. So this consumer will consume all the messages from partition 0. This has been assigned partition 1. Okay, so this is within topic. You are managing messages in a really better way over here. Okay, now there is also a concept of consumer rebalancing, wherein it's a process of redistributing the topic partition among the consumer within the consumer group. Okay, and this is a process that ensures that consumer is assigned a fair share of partitions to read and process. Okay, and it happens automatically when consumer joins or leaves or changes within the group, or when new partitions are added. Okay, so this is the concept of consumer rebalancing that is being done at the Kafka level as well. Okay, I hope this entire thing is making sense. Okay, and I hope you are able to grasp this. Now let us talk about offsets. Now what is offset? So offset, just to put it in one line, okay, it's like a bookmark of your last read message. Okay, for example, in WhatsApp, let's say you read 10 messages yesterday and then you went offline. There was no network, you went offline, you switched off the internet. Now today when you came in, you have more messages, right? So you won't be like, you will be seeing those 10 messages that was sent yesterday as well, but you will have a bookmark that WhatsApp will show you that, hey, from here on you have not read the messages. So these are your unread messages. Okay, so if you received 20 more messages today, so it will tell you that, hey, 10 messages were yesterday. Okay, this is yesterday, and then from today you have received 20 more messages and those are unread. It will give you a clear bifurcation and you will know, okay, this is where my unread messages start from, right? So that is a bookmark, right? So in Kafka, offset is a number showing the position of last message read. Okay, so for example, within partitions here, you can see on the diagram, within partition you will have offsets, which means that is numbering. So 0, 1, 2, 3, 4. So this is the message number. So offset basically is the message number you last read. I hope this is making sense. Okay. Now going further, we'll talk about the concept of message brokers, and we'll talk about Zookeeper as well. Okay. Now Kafka, you can have multiple instances of Kafka running. For example, you can have here, you can see there are 4 instances of Kafka running, and together all these instances can run in a cluster because they're serving the same application. Now, one question you might ask that, hey, why I want to run 4 instances of Kafka? So one reason for that is for better managing the load. So if you have like tens and millions of messages coming in every minute, every second, there is a lot of load on your server, then in that case, you can have multiple instances of Kafka brokers running and you can run them together in a cluster, right? Now, what happens is, if a lot of things are running in a cluster, you will need some sort of a manager who will keep track or who will help coordinate all the brokers in a cluster, right? So when I say broker meaning one instance of Kafka. I hope this is making sense. So here there are 4 instances of Kafka and it's running in a cluster. Okay. So you would need some sort of a manager that will help coordinate and coordinate different Kafka brokers and track which broker has which data and all of that, right? So that is where Zookeeper comes into play. Okay, so here I have Zookeeper. You can see the Zookeeper. So Zookeeper is a service. Okay, it's something that helps manage the entire Kafka cluster over here. You can see over here it is managing. You can see 2 down arrows over here, right? And here you can see there are tons of producers that are sending in message to Kafka, and there are tons of consumers who are consuming the message from Kafka. Okay, so what is Zookeeper? Zookeeper will help manage and coordinate Kafka brokers. Okay, it keeps tracks of different things and it will manage this entire cluster. Okay, now I'll also mention over here that in the newer versions of Kafka is moving away from Zookeeper, because normally when you install Kafka, you have to also install Zookeeper first. You have to start Zookeeper and then you have to start Kafka. So in newer versions, they are getting rid of Zookeeper so that there is less dependency and it is somehow internally integrated into Kafka itself. So you don't have to install 2 softwares to just install Kafka, and everything else is taken care. Okay, but I'm showing this to you still because it's an important concept and you should definitely know and understand what Zookeeper is, because if your company is using the older version of Kafka, then you will hear this term frequently, and I don't want you to miss out on this. Okay, so I hope this is making sense. Okay, now what I have is I have a table, okay, where I have the terminology, okay, what is its meaning in the WhatsApp analogy, and its actual definition in Kafka terms. Okay, I repeat, the terminology that we'll talk about, I have its meaning in WhatsApp analogy and also its definition in the Kafka terminology. Okay, I've done this so that you understand things in a better way. Okay, because WhatsApp is something that everybody uses. So not only WhatsApp, if you use some other chatting software, you can compare it with that as well. Okay, but WhatsApp is most popular, so that is why I've used WhatsApp here. Okay, now let's talk about each term. Event. What is an event? In WhatsApp, event is nothing but a message sent. Okay, now if you talk about event in Kafka, a single unit of data or a message that flows through Kafka. So that is what an event is. What is a producer? So in WhatsApp terminology, producer is nothing but the sender of the message. If you send the message, you are the producer. But in case of Kafka, producer is the application or service that publishes events to Kafka topics. I hope this is making sense. Consumer. What is consumer? So consumer is the one who reads the message. So if you read the message, if your mom read the message, if your friend read the message, he is the consumer, he or she is the consumer. And in case of Kafka, an application or service that is subscribed to Kafka topic to read messages, they are the consumers. Okay, now there can be one or more consumers when it comes to WhatsApp and Kafka both, right? Topics. Now what is a topic? So when it comes to WhatsApp analogy, topic is nothing but a group chat. For example, you will have 10 group chats, right? One will be for work, another one will be for friends, third one will be for close friends. So likewise, you'll have different group chats. So that's a topic, right? And in Kafka, a topic is nothing but a category or a name to a particular feed to which records are sent by producer. So it's a way of segregating messages for different types within Kafka. I hope this is making sense. Partition. Now what is partition? Partition can be, in WhatsApp terminology, it can be sub-channels or sub-threads in a group for faster delivery, okay, or faster segregation or better segregation, I should say. But in case of Kafka, a topic can be split into partitions to enable parallel processing and scaling, right? So this is what partition is. Now talking about more consumer groups. So consumer group is nothing but a team of people processing message together in WhatsApp. But in case of Kafka, it's a group of consumers sharing the workload of reading from a particular topic, because that particular topic might get lots of messages per second. So to process them faster, you will deploy more consumers within a group and you'll assign it to a particular topic, and internally they'll be assigned with different partitions, right? Offset. So offset is a bookmark in WhatsApp of last message read. And in case of Kafka, it's a position or a marker in a partition that tracks how much a consumer has read. What is a broker? A broker is nothing but a WhatsApp server storing and routing messages, right? WhatsApp is installed on your phone, but you will have a server somewhere in WhatsApp. Like WhatsApp must have deployed a server that is storing and routing your messages. But in case of Kafka, okay, there will be a Kafka server that will store and serve Kafka messages. Okay, what is Zookeeper? So in case of WhatsApp analogy, Zookeeper is like a group admin who keeps tracks of who is doing what. He has the rights to coordinate with everyone, remove anyone, add people. So likewise, in case of Kafka, Zookeeper manages metadata, leader election, and configuration in Kafka. It is also soon to be deprecated, like I said, okay, but it's good to know. It's important that you understand and know this, okay. So I hope this is making sense, and I hope you have been able to follow along so far. Also, I would want to talk about some more concepts that exist. And these are the concepts or terms, I should say. These are the terms that you will hear frequently if you're working with Kafka. So one term is retention. Now, how this is used is, what is the retention of messages in Kafka? What this means is, retention just tells you how long Kafka stores messages. It's like a chat history. So it might be configured to store messages for 30 days, 90 days, 1 month. So all of that, right? So that is what retention is. Replication. So Kafka keeps copies of messages for safety. So that is what is known as replication. Producer acknowledgement. So once the message is sent, producer acknowledgement is a way to confirm if the message was successfully sent. Right? So this is something that you will hear, but I thought I'll tell you the definition. Dead letter queue, which is also known as DLQ. If there is any message that has been failed, so DLQ or dead letter queue is a place to store failed messages rather than losing them forever. So failed messages are stored there, right? Kafka Connect. So Kafka Connect is a tool to connect Kafka with databases, cloud, and so on. And then you have concept of Kafka Streams, which allows you to process data inside Kafka in real time. So these are some concepts that you should be aware of. Okay, I'm not saying you will always hear these, but you might hear these, and I want you all to be 100% comfortable and knowledgeable about Kafka. Now, coming back to the definition that we saw in the beginning, Kafka, like Apache Kafka, I should say. Okay, Apache Kafka is an open source distributed event streaming platform. Okay, are you aware of these terms now? Open source meaning it's freely available, it's open source. Distributed meaning it can run in distributed environment. It can have multiple instances running. It can run in clusters, right? Event streaming, I hope you're aware of what event streaming is. It's just a continuous stream of data. And with this, I hope you're completely clear as to how Kafka works internally and you're geared up for practical. I hope this has been awesome. Now, let's talk a bit more about Apache Kafka. So here I am on the official website of Kafka, which is kafka.apache.org. And you can actually search for Apache Kafka on Google and you'll actually see the first link over here. You can see, and I'll tell you, it's an open source system developed by Apache Software Foundation. Okay, so Apache Software Foundation is the one behind this software. Okay, and you can see this is what Apache Kafka is. You can see it's an open source distributed event streaming platform. Now you can see over here another thing over here is 80% of all Fortune 100 companies trust and use Kafka. This is really big. Okay, you can see some stats over here, like for manufacturing 10 out of 10, banks 7 out of 10, insurance 10 out of 10, and in telecom sector 8 out of 10 use Kafka. You can see the full list as well over here. Okay, so this will give you some gist of capabilities and what Kafka is. So you can see over here capabilities: high throughput, okay, and scalable, permanent storage, high availability. Okay, and ecosystem is also really great, trust and ease of use. Okay, now just to give you a gist of the history of Kafka. So Kafka was originally created by LinkedIn. Okay, if you know LinkedIn, linkedin.com, you all must have used LinkedIn at some point in time in your life, okay? Or you must have heard about it at least. So LinkedIn created Kafka in 2010. Why? To handle huge amounts of data in real time, like user activity, logs, and metrics, and so on, right? Now, existing tools at that time were slow, unreliable for this kind of messaging, right? And LinkedIn created itself within the company to solve its own problem. And then in 2011, they open sourced Kafka through Apache Software Foundation. And then tech giants, like other tech giants like Netflix, Uber, Airbnb, started adopting it quickly because it could handle millions of messages per second. It could offer real-time processing, and also it could help establish data pipelines across apps and services. Okay, so this is some history that I want to give you a gist of. Okay, if you go to here, there are really helpful links that I would want to give you a gist of. So introduction, first of all, you can get introduced to concepts like event streaming and why you should make use of Kafka and how does Kafka work well in a nutshell. So all of these explanation, have been mentioned over here. And this is like a diagram of Kafka topic, and internally they have partitions, they have storage, and then there is a producer that is pushing in the message. So this is something that we already know and we have already discussed. Okay, but this is what it is. And then over here you will have quick start. Now, what is quick start? So here we'll talk about like installation, like how can you start the Kafka environment and set it up. Okay, now here you can see there are different ways of installing Kafka. So you can download the files. Okay, You can make use of JVM based Apache Kafka Docker image. You can make use of Docker. Okay, there are two images. Okay, you can see over here. So you can make use of them. And here there are some commands given for you to create topics, events, and all of this. If you want to try out the Kafka CLI, you can make use of this. Okay, so it's a very straightforward documentation that you can go through. Okay, now coming up over here, you'll also see use cases. Now, what are the use cases where Kafka can be used? So one is messaging. Okay, it works well as a replacement for more traditional message broker. It can make use of, you can make use of it for website activity tracking because it is great for event streaming, metrics, okay, log aggregation. If you have lots of logs that are being generated by multiple applications, you can use Kafka as a log aggregation solution, stream processing, event sourcing, commit log. There are a lot of use cases, and this is just a beginning. So you can click on it to learn more and get the link over here. Okay. Now, I would like to mention over here that in newer versions, okay, in the newer versions of Kafka, Kafka has introduced K-Raft mode. Okay. Now, K-Raft mode is a mode wherein Zookeeper is not needed. So, Zookeeper was needed earlier, wherein you had to have Zookeeper and then you had to start Kafka. Okay, and if like Zookeeper will act as an admin that will help you manage everything. Okay. Now, initially, in the initial versions of Kafka, okay, we had Zookeeper. So, why did Kafka use Zookeeper before, and now why it's moving from Zookeeper-less version? Okay, because Kafka was originally built to manage metadata itself. Okay, it wasn't built to manage metadata itself. Okay, so Kafka wasn't built to manage metadata itself. So things like what partitions exist, what topics exist. And there is a concept of being a leader for each partition. Who is the controller? Who is controlling everything? So for these tasks, okay, Zookeeper was introduced, and Kafka was using Zookeeper to help keep track of broker metadata. Okay, to maintain the configuration. So for all of that, for managing all this stuff, there was Zookeeper involved. Okay. Now this had drawbacks wherein a lot of people said that there is an extra moving part to deploy or manage Kafka. Okay, there is a dependency of Kafka on Zookeeper. Okay, and that is why K-Raft mode, which is Kafka Raft mode, was introduced, wherein Kafka itself is managing the metadata on its own, and it is removing the need for Zookeeper entirely. Okay, so that's something that you should be aware of. Okay, and I hope this is clear to you as to what Zookeeper mode is and what K-Raft mode is. Okay, so if you read the documentation, you will learn more about K-Raft mode. You can see over here K-Raft versus Zookeeper. Okay, so it talks about a lot of stuff over here, and I'm just giving you a gist of all that is there in documentation. And this is like a helpful resource if you're serious about learning and mastering Kafka. Okay, I hope this has been useful. Now it's time that we begin installing and setting up Kafka onto our system. And to do so, I'm going to need or make use of Docker over here. So I'm here on docker.com, where I would encourage you to download Docker Desktop. Now, this is the easiest way to set up Docker onto your machine. So if you hover on this button, you will see download for Mac different versions like Apple Silicon, Intel, Windows, and even different versions of Windows and Linux. So depending on your machine, you can download Docker Desktop and start Docker Desktop, because we are going to run a few Docker commands. And what commands are we going to run? So we are going to run these two commands over here. Okay, so these are the commands. Okay, but before that, I'll tell you, like, I have Docker Desktop up and running over here. I also have the terminal of my choice up and running. All right, so I have this setup done already. You can do so. Installing Docker Desktop is very simple. It's just like installing any other software onto your system. So just come over here. Here you will see these two commands. Okay, you will find these two commands attached along with this lecture. So just feel free to take a look at this command. If you don't want to type in, you can basically copy it from there. Okay. Now, what these commands do is basically these commands are used to start two containers. So this first container is of Zookeeper. The second container is of Kafka over here. Okay, now let us understand each command. So here first what we are doing is we are running this Docker. We are running this particular container in a detached mode with this -d. So Docker run says run this container or start this container, and it runs in -d, which is detached mode over here, which means in the background. All right. Then we are giving a name to the container, which is Zookeeper. This is what we are calling our container. And then we are doing a bit of port mapping. So here we are specifying the port. Now what this is going to do is it is going to map the port 2181 from the container to that of your machine over here. So left hand side port is for the machine and right hand side port is for within the container. So that is what we are doing. Okay, and 2181, because this is a default port for Zookeeper. So what we are saying is we are saying inside container you have this port 2181. So map this to the one on the host. So if you say localhost 2181, it is going to connect to Zookeeper running inside the container. That is what it's going to do. Then I have -e. Okay, I am making use of -e couple of times. And what this is going to do is it is going to help me set the environment variables for the container. And I have a couple of environment variables like Zookeeper client port and Zookeeper tick time. So Zookeeper client port is a variable that tells Zookeeper which port to listen to. Again, it's 2181 over here. And then I'm having Zookeeper tick time, and this is an internal config. So this is an environment variable for internal config for heartbeat timing, and which I'm setting it to 2 seconds over here. So this is the converted version over here, and this is actually 2 seconds. Okay, and you can leave it as it is. Okay, I'm not modifying this. And here then I have the image name specified. Okay, so you can see this confluent inc /cp-zookeeper, and this is a version. Okay, so this is the Docker image that we are using. Now what this Docker command does, this entire Docker command, this is going to start the Zookeeper server in Docker that Kafka will connect to in the next step. So this is step number 1. And then the step number 2 is about running Kafka. Now what this does is this is going to start Kafka again in the detached mode. So I'm saying Docker run -d, container name I'm setting as Kafka. Kafka runs by default on 9092. So I'm saying like map the container's 9092 port to that of the 9092 on host machine over here using -p. Then I'm specifying environment variables using -e over here. And there are few environment variables that I'm setting in. First is Kafka broker ID. Now this assigns a unique ID to this Kafka broker. And if you're running in clusters, so this will be really helpful. Okay, but we are not running in clusters. Okay, we are having a individual setup. So then we are specifying this over here. Kafka Zookeeper connect. Now what this is doing is this is specifying or telling Kafka where Zookeeper is located using the container name Zookeeper. So you can see Zookeeper :2181. So this is the container name for Zookeeper. Okay. Then we have Kafka advertised listeners over here. And this tells Kafka how to advertise itself to the client. So plain text meaning no encryption is there. Okay. And it is specifying this URL. And then we have Kafka offset topic replication, which stores the consumer offset in an internal topic. And this sets how many replicas and all are needed. So here we are setting it to 1. Okay. And then we are mentioning over here link Zookeeper. So this allows Kafka to talk to Zookeeper container by name. Okay. And this is what we are doing. And here we are specifying the Kafka image name. So we are going to run these two commands on our local machine. So first we are going to need Zookeeper. So I'm going to come over here on the terminal. Make sure you have Docker desktop up and running and run this command. Just press enter. Okay, so it's saying invalid, Docker invalid reference format. So I'm getting this error because, my terminal over here is not supporting these backticks. Okay, so here you are seeing these backticks. This is for new line. Okay, so my terminal is not supporting this. So what I'm going to do is I'm going to quickly come over here. And I'm going to get rid of these backticks really quickly. Okay, so I'm going to press backspace over here. Okay, there is one over here. This one I'm going to get rid of. Okay, so on bash based terminals, this would work fine. Okay, but on my terminal, it's not working. So I'll just press enter now. And you can see now it's working fine. And you can see I'm getting this message first that it's unable to find this image. So if the image is not present locally onto your system, you'll have to have some patience because it is going to fetch the image from Docker registry and it is going to get it locally. Okay, and once the download is complete, it is going to run this particular image as a container, and you will see it running over here. Okay, so we'll wait for a while until this completes. How much time it will take? It depends and varies from system to system. So if you have a good network speed, a very good system, powerful one with good internet connection, this will not take much time. But we'll wait for a while, a few minutes. So you can see the execution was complete. It said downloaded newer image for this particular image name, and it has given some value over here, which is the container ID. Okay, which means the container is up and running. And if you come over here, you'll see Zookeeper up and running, and the ID that was printed over here, FE19E. This is the start. So that is something that you'll see over here, FE19E. Okay, that's the container ID, and this is the truncated version, and you're seeing the complete version here locally being printed. So Zookeeper is up and running, and now it's time that we run Kafka over here. So I'm going to paste this over here. Okay, pasting long text, yes, and I'll just get rid of these backticks over here for a while. So you can see I've removed the backticks because my terminal is not supporting them. I'm going to press enter now after backticks are removed. Now you're going to see sorry, it's not backticks, or it's a backward slash, not backticks. Okay, backticks is something else. This is backward slash, and this is usually used in commands that are multi-line for better formatting. Basically, you can format the commands in new line. Okay, but if your terminal does not support, that's absolutely okay. Now you can see over here, this completely executed successfully. It did not find the image, so it pulled the image, and it has started running this container. And if you see over here, you'll see Kafka also up and running. So you can either check whether the containers are running over here in Docker Desktop UI, or you can simply say Docker PS over here, and you're going to see the list of all the containers. So you can see Kafka is up and running, and Zookeeper is also up and running. Okay, but if you find this to be more intuitive, feel free to use this. All right, now we have now we have Kafka and Zookeeper running inside Docker, or running as Docker containers. I hope you have been able to follow along, and I hope this has been useful so far. Now is the time that we are going to work with the CLI that we get inside the container. So I already have a couple of containers like Zookeeper and Kafka running. So if you want to check what containers are running, you can simply run Docker PS, and you will find I have a couple of them. So this is the first one, this is Kafka, and then I have Zookeeper running. I have other containers as well. Okay, I'm doing some other development, so these are some other containers, but these two containers is what you should find if you have executed and done everything correctly to run Kafka on Docker. Okay, or using Docker. So what I'm going to do is, first I am going to get the CLI access to the Kafka. So for that, I'm going to enter the Kafka container. Now Kafka container is running with the name Kafka over here. Okay, so what I'm going to do is I'm going to say Docker exec. I'm going to say -it and Kafka bash, something like this. Now, what does this command do? So this command is telling Docker that, hey, take me inside the container named Kafka so that I can run commands inside that environment. Okay, and if you want to understand what this command is, so here I have Docker. I'm making use of Docker CLI to execute this. I'm saying exec means execute a command inside a running container. And then I'm saying -it. So I means keep the input open, and T means allocate a terminal. So it's using in interactive mode. I'm specifying the container name, and then I'm making use of bash over here. So we are saying that open a bash shell, which is a command line terminal inside the container. That is what we are seeing with this particular command. Now, if you have a container with this name Kafka up and running, and if you press enter, you will enter this particular container. You can see the terminal has changed. Suddenly the prompt has changed, and now whatever commands I run will run inside the container. So using that command, we have now entered the container, and whatever commands we run will be inside the container. Now inside the container, the first thing I'm going to do is I'm going to create a topic. Okay, so I'm going to say Kafka, and I'm going to say -topics, and I'm going to say create to hyphen topic, and I'm going to specify the topic name. So I can specify the topic name as my topic. Okay, something like this. Okay, and I'm going to say bootstrap hyphen server. We'll understand what everything means. Okay, but for now, let me type in this command, and you can type simultaneously with me hyphen partitions 3, and I'm going to say replication factor. Replication factor is that of 1. Okay, so let's understand what we are doing. What we are doing is we are creating a topic over here inside Kafka, and this is a complete command for this. Now for this, we are making use of something called as Kafka topics. Okay, now what is Kafka topics? This is a Kafka CLI tool that is used to manage topics, and it exists inside the container that we have up and running. And then I'm saying hyphen 2 times create. Now using this option, I'm telling that, hey, I want to create a topic. Okay, so Kafka topic hyphen create, and I'm specifying the topic name over here. So I'm saying hyphen 2 times topic, my topic. So this is the name of the topic that I am giving. So I'm simply giving my topic as the name. But if you're working in a real world production grade environment, the topic can be named as user signups, order events, something like that, whatever use case you're creating it for. Then I'm specifying bootstrap server over here. Bootstrap server is localhost 9092. So this tells the command where Kafka is running, and it's running on localhost 9092, means Kafka is running on this particular port number and this particular machine. Okay, localhost because we are already inside the container. Then I'm specifying the partitions. So I'm telling Kafka that, hey, please create 3 partitions, or please create this topic with 3 partitions. Okay, and then I'm specifying the replication factor. So this tells Kafka how many copies of each partition to maintain, which means replicas. So I'm specifying 1, which means no backup. There will only be 1 copy. If you want to have backups, so you can specify 2 or 3 over here. So that can be taken into consideration. Now after this, I'm going to just press enter. Okay. All right. So press enter, and you can see over here the confirmation is created topic, my topic. So topic has been created. Now this confirmation says that topic is created, but we should have the ability to list the topics as well, right? So I'm going to say Kafka topics hyphen list, and let us list all the topics that exist. So I'm going to say Kafka topics list all the topics. I'm going to say bootstrap server localhost 9092. And if I press enter, you will see my topic is the only topic that exists. And what this command does is, this command is telling me the list of all the topics. I'm making use of Kafka topics again. This is a tool that we are making use of to manage topics. I'm saying hyphen 2 times list. So this is an option that tells us to list all the topics, and I'm specifying the server. So this is the server location, and this tells where Kafka is running, and I'm getting 2 topics over here. You can create 1 more topic if you wish to. Okay, so not this one, but I'll have to run the previous command. Okay, so this command over here. So here, instead of my topic, I can say my topic 2 over here, or my new topic. I can say new topic. So I've changed the name of this particular topic over here, and instead of 3 partitions, I'll specify 2 partitions only. Let me say enter. So you can see this topic is created. Now let me list this. So the moment you list, you will see now 2 topics exist. Okay, so yes, this is done. Now we also have the ability to describe a particular topic. So if you want to see the details of any of the topics, you have the ability to do so. So like always, you'll make use of Kafka topics, and you'll say describe over here, describe, and I'll say topic, my topic. Okay, over here. So my topic is the topic that I want to describe, and I can specify bootstrap server and a localhost 9092, and I'll press enter. Now the moment you say that, you're going to see, like, this is a topic. There are 3 partitions. Okay, you can see the replicas. So you can see all the details of this particular topic, right? You can see partition count and replicas as well. Okay, if you zoom out, you'll see the complete details. Okay, now I can again run this command to describe the other topic. So I can just change the name. This is new topic, and you'll see there are two partitions now for this particular topic. Okay, and this is what we specified when creating the topics. So I hope so far you have good clarity as to how you can create topics, describe them, and see the partitions as well. Okay, now the next step is we would be producing messages. Okay, and we'll be producing the messages through the console itself. And for that, we are going to make use of a client tool, which is known as producer client tool, which Kafka provides. And I'm going to make use of it to start a producer. So I'm going to say Kafka console producer, something like this, and I'm going to say topic, because we need to mention the topic as to which topic we are producing the message for. So I'm specifying the topic over here, and then again I'm going to specify the bootstrap server over here, which is localhost colon 9092, something like this. Okay, now what this command is doing is this is starting a producer which is going to listen to the messages in the live mode. Okay, so you can type in anything over here, and the moment you press enter, that becomes one message. So every line becomes a message, and you can type in whatever you want over here. Okay, so for example, I can say, hey Kafka, I'll press enter. This became one message that was sent to this particular topic. Hello, how are you? Something like this. This became another message. So this is like a live producer input mode that we have started by running this command that you saw over here. Okay, a live producer input mode wherein whatever you type in becomes a message. Now to stop this, you can press Control C or Command C on Mac, Control C on Windows and Command C on Mac. But I'm not going to do that. Okay, I have one producer up and running over here, right? So I'm going to just trim this out, something like this. I'll just zoom out a bit over here. Okay, what we can do is I can start one more instance of this terminal, and I can start a consumer over there. So let me open up one more instance. So here you can see I have one more instance of the same terminal. Okay, what I'm going to do is I'm going to again log in to this Kafka container. Okay, and I have already executed the command, which was docker. Oops, so it is docker. So this is the command I've typed in, docker exec it Kafka bash. So I'm going to log in to interactive mode inside this particular container over here, and I'm going to start a consumer over here. So I'm going to say Kafka console consumer. So this is a consumer tool that we are making use of, and this is going to allow us to listen to messages from a particular topic and print them to your terminal. So like this particular thing is allowing us to produce messages in real time in interactive mode on terminal. This is going to show us the messages that are sent to a particular topic. Okay, so I'm going to say topic over here. I'm going to specify my topic, and I'm going to say bootstrap server over here like so, and I'm going to say localhost 9092, and I'm also going to specify one couple of options like from beginning, something like this. Okay, so from beginning tells Kafka to start reading from the start of the topic, like old messages too. And I'm going to press enter. Let us see what we see over here. Okay, so you can see a couple of messages now being printed. Hey Kafka, hello, how are you? This is something that we just printed over here. You can see this is something we printed over here, and we are seeing the output over here, right? So let me bring them side by side over here, something like this. Okay, now the moment I type in over here, so I can say hello consumer, enter, you'll see hello consumer appear over here. Okay, if I say hello producer, okay, you'll see hello producer appear over here. If you say hello, I am enjoying Kafka, you're going to see that message appear over here. Okay, why is it appearing over here? Because you have a consumer listening to these messages on this topic. It's listening to this topic, and that is why you are seeing the messages appear over here, and you're sending the messages to same topic over here. You can see the topic name is very much the same. Okay, and that is why you are seeing the output. If you listen to some other topic, or if you're producing message for some other topic, you won't see the messages appear over there. Now let me show you something. I have started another instance of terminal. So this is the third instance of terminal, and I'm going to run the command over here. So I'm going to say docker exec -it Kafka bash. Okay, and I've logged into Kafka. I'm going to list all the topics over here. You can see there are two topics like my topic and new topic over here, right? So my topic is where we are sending in everything. Okay, so what I will do is I'll create a consumer over here which is listening to new topic. So you won't see messages coming in over there. So I'll just copy this command over here, something like this until here. I'll copy this, I'll paste it over here. Okay, and instead of my topic, I will have a new topic like so. You can see new topic is started. And now if I say hello, my topic. Okay, this is going to my topic, not to new topic. So you will see that appear over here, but not over here because this is listening to another topic and not to the same topic. Okay, so here we are listening to some other topic, and let me switch this. Let me switch this to like my topic over here. So I'll start listening to my topic. Okay, my topic. So you can see my topic, and it will print everything now. Okay, now if I say hey there, okay, you will see hey there appear over here as well and here as well, because these two are listening to the same topic now, right? So you can see the message is broadcasted over here and it is going to all the consumers that are listening. Okay, now what you can do is you can start the consumers with a group. You know, in a group, one message will be read by only one consumer from the group and not by the all. So Kafka ensures that messages in a topic are divided amongst consumer in the same group. So right now we don't have these two consumers in the same group because we have not specified any group over here in the command that we ran over here, right? So they are not in the same group. But what I will do is I'll just stop these both. Okay, I've stopped both of them. And now what I will do is I'll specify the group as well. So over here, just after this last thing over here, I'll specify group. Okay, and I'm going to say group is my group. You can specify any name you wish to. Okay, so this is my group. So now this is listening with my group, and here I will start this again, and with the same command, I'll have group, and I'll say my group again. So I'm assigning both these consumers to the same topic and the same group. Okay, so now you will see the message won't be replicated. So you can see these messages are read by him. Here you won't see these messages. Now let me say 1, 2, 3, 4, and 5. Okay. So you will see 1, 2, 3, 4, 5 being listened by this over here, this particular consumer, but not by him because they are in the same group over here. Now one thing you will notice over here, and if you send more messages, okay, they are only being read by one consumer, not by both. And why is this? Because all these messages are going to a single partition, and this particular consumer is likely listening to partition 0. So there are 3 partitions, right, in our topic. So this is listening to partition 0, and all the messages by default are going to 0, and that is why this is listening to all the messages. And there is no message that is going to partition 1 or 2, and that is why you are not getting any message being printed over here, right? So what we will have to do is we'll have to add a message key when producing the messages, because Kafka uses the key to hash and assign partitions. Okay, so what I'm going to do is here in the producer itself, I'm going to stop this producer. I'm going to create one more producer, but this time what I'm going to do is I'm going to specify bootstrap server. It's the same command, but after bootstrap server, I'm going to specify property, and I'm going to say parse dot key over here is equal to true. Okay, so we are parsing the key, and then I'm telling that a property, and here I'm going to say key dot separator is equal to colon. So if I pass in the message as colon, like if it has a colon, the first part will be taken as key over here. That is what this tells over here, right? So I'll just press enter. Let us see. So I'll say user 1 colon hello. So you can see, okay, we get an error over here. So what is the error? No key separator found. So I get this error because I've misspelled this thing over here. Okay, so I'll just shut this again. I'll just run this. So it's SEPARATOR. Arator. Okay, I just mentioned E over there. So after making changes to this spelling over here, I have started this producer, and I've also started these two consumers, restarted the consumers is what I would like to say. Okay, and they all are connected now. And let me say user1, and I'll say hello. So let us see where this message goes. So this went over here in this particular consumer. Now I'll again say, okay, I'll say user 33 bye. Let me see where this goes. So this is coming in the same consumer that is listening. Let me say user 33, or let me say 055876, and let me say bye. Okay, so you can see this now came over here in this particular consumer, right? So two messages went there, one came over here. Okay, and you can again run something over here. You can say wow colon 0, what are you up to, something like this. Okay, so you will see this message go over here. Okay, now what is happening over here is we are making use of a key. So this is a key. Okay, you can say a routing key, and this routing key here we have mentioned. So when we are starting the producer, we have mentioned that parse a key. We are saying like parse key true, and then we are saying the key separator is colon. So the first part of this message becomes the key, because there's a separator that we have mentioned, and this part becomes the message. Hello becomes a message. Now what happens is here user1 is hashed into a key. So Kafka will hash the key, which is user1, user 33, user 55876, and it will assign it to the different partitions based on that hash. Now there is a possibility like two keys might have a similar partition because of the hash value that was generated from them. Okay, so you won't know which by putting in which key it will go to which partition, and which user or which consumer it will be shown on. Okay, but you can experiment over here. So I can say user, and I can put in some other value, and I can say hey there. Okay, and you can see it came over here, right? So 4 messages went there and 1 came over here. All right, so based on which partition it goes to, the consumer listening to those partitions, you will see the message. I hope the importance of key is clear to you all. Okay, we can even see the offset basically, or we can view consumer group offsets. So what I can do over here is let me start a new window. So I started a new window and I've logged in to the console. Okay, now what you can do is you can see the offsets, and this will tell you how far each consumer has read, the partition assignment, the offset lag meaning how much is left to read, all of that. So you can say Kafka hyphen consumer groups over here. You can say bootstrap server. Okay, bootstrap server is localhost colon 9092, and you can say describe over here, and you can say group my group. So this is your group that you have created, and this should tell you quite a few things. You can see over here, let me zoom in a bit, or let me expand this a bit. So you can see over here my group. So this is the topic. You can see the partition it is listening to. Okay, so you can see the couple of okay, so let me zoom out a bit. Okay, so this will be a much more, okay, you can see now. Okay, this became very much smaller. Okay, but I'm not sure if it's readable to you. Okay, it's readable. The text is small. So I did this because you can read it easily. So, you know, everything is now in one line. So you can see consumer ID. This is the consumer ID. So there are this two consumer IDs are same, you can see. And this is the third one, right? So you can see this one, like one consumer is listening to two partitions, 0 and 1. You can see these two consumers are listening to two partitions, 0 and 1. And then you have one more consumer which is listening to only one partition, right? And you can see over here current offset is 18, log end offset, and lag is 0. Lag means how many messages are pending to be read over here. So if you stop both the consumers, so if I stop both the consumers, this one and this one, and then if you start sending in the message, you can say user 1, 2, hey again, and then if you try to describe this, okay, not this one, if you try to describe, so let me come over here and let me describe over here. Okay, if you try to describe, you'll see lag is 1 because there is one message that is pending to be read. I hope this is making sense because we shut both the consumers. So now there is a lag of 1, right? So this is telling us how far the consumer has read, partition assignment and offset log. You can check using this, right? So I hope this has been useful. This entire demo using CLI has been useful, and I hope you have got a good clarity as to how Kafka works. This was the best part over here is we ran everything within console. Without installing any other graphical user interface, we did everything with the help of commands, right? So that's the best part. We do not have any other external software except Docker, because if you're a developer, Docker is essential, and it's likely that you will have Docker installed onto your system, or you must have worked with Docker in past. So I hope this has been useful so far. So now is the time that we begin setting up a producer. And what I'm going to do is I'm going to head over to Spring Initializer. And here you can see I'm here on this website, start.spring.io. I'm going to make sure that I select the valid settings and configuration that I need, and we'll move on to the next step. So I'll select Maven over here. I'll make sure Java is selected, and I'll select the latest version of Spring Boot, that is non-snapshot. And here in project metadata, I'm going to enter the group and the artifact. So I'm going to enter demo. And here I'm going to say as artifact is producer, because this is the producer. And I have jar selected, and we can have latest version of Java. All right. Now here from the dependency list, I'm going to say add dependency. I'm going to mark this as a web project, and then I'm going to select Kafka from here. Now here you'll see a couple of dependencies for Kafka. So I'll just select Spring for Apache Kafka and not the streams version. So I'm selecting this. This is what your pom.xml will look like. All right, so I'm just going to quickly say generate, and after generating, you'll get a zip file which you can save it onto your local machine. So I've got the zip file downloaded onto my local machine into the folder of my choice, wherever I'll be working, and I'm going to quickly unzip it over here because we need the unzip version. And now we can delete the zip version of the project and just have unzip one. Now we need to open this particular project in IntelliJ IDEA. So I'm going to head over to IntelliJ, and this is my welcome screen. I'm going to say open over here and navigate to the folder location. So here you can see I've navigated to producer that we just unzipped, and here you can select pom.xml. So I'll select this and I'll say okay over here. Okay. And this will open this as project, but you can open this as project over here. Wait a minute. Or you could also open this you can just open the parent directory as well. So what I would do is I would come over here, I would say open, and I would just open this Kafka folder at the top, okay, which is the parent directory. Now I'm doing this because you're also going to have consumer project later on, and I don't want to have a separate instance of IntelliJ for that. So I'll select Kafka. I'll say open it in this window itself. And you can see Maven build scripts found. So I'll just say load the producer. Okay. So this is just going to load the producer. And you can see this is indexing all the libraries. Now, if for some reason you don't see this Maven build script file and it's not identifying this as a Maven project, then in that case, you can go to this file. You can say new module from existing sources, and then you can go to the folder. So here under Kafka folder, I have producer, and I'll select pom.xml over here. Okay, so what this will do is this will open this particular file as or this particular project as a Maven project over here. Okay, this you have to do only if your producer project is not being identified as a Maven project. So it was identified for me as a Maven project, but if just in case, so when I just opened this Kafka folder, I saw a pop-up over here on the right hand side. On the right hand side that this is a Maven project and Maven build scripts identified. Do you want to load it? And that's how it got identified, right? So you can see over here, you can select the directory, or you can select any directory with existing sources like Eclipse project, Maven project, Gradle project. So be sure to import it this way, and then you will see this little icon over here, like the blue triangle, blue rectangle it is, and you'll also see the Maven icon over here. Okay, so this is done. Our project setup is done. So now what I will do is I'll start setting up the producer. So I'll head over to src, main, resources, and application.properties file. Now you can continue using application.properties, but I would prefer renaming this. So where's the refactor option here? I'll prefer renaming this to YAML format. Okay, you can continue using properties. That's absolutely all right. There's no issue as such. And I'll convert this to the YAML format. Okay, like so. Okay, so this is done, and we have the application name set up. Now what I will do is I'll add one more property over here. So I'll say Spring Kafka. Yes, I'll get a red mark because this key is being duplicated, but that's fine. Ignore it for a while. Okay, Spring Kafka. I'll say producer. So this is producer, and I'll say bootstrap servers. And then I'll say localhost :9092, something like this. Okay, so here I'm specifying the connection URL for Kafka, and I'll have to get rid of this duplicate key, which is Spring over here. And this is the final configuration as to what it will look like. Okay, now we need to have a way to produce messages, right? The producer will produce the messages and it will send it to Kafka topic. So for that, I need a API because we also need to trigger the message. So here I'll head over to Java, and here I'll create a controller and I'll say Kafka producer. So this is the class that I'm having over here. Okay, and here I'll call this as a REST controller, and here I'll have request mapping as well. And here I'll say /API, something like this. So I'm mapping this entire controller to this endpoint using this request mapping endpoint, not endpoint, this is request mapping annotation. So this is the endpoint to which all the mappings within this controller will be mapped using this request mapping annotation. And REST controller is doing the job of making this as a RESTful controller, right? Now what I will do is here I'll say post mapping, or I can simply say get mapping, something like that. Okay, or let me keep this as post request only. So I'll say post request, post mapping, and /send. Okay, so this is the endpoint that is going to simulate things for us. And I'm going to say public string send message over here. And I'm going to say request param. And here I'm going to say string message, like so. Okay, and this is what the method will look like. Okay, there is some code still pending, so we need to send this message to Kafka and to a Kafka topic. So we'll be doing this operation. We'll be sending this using Kafka templates. I'm going to say private final Kafka. You can see there are quite a few classes that are available for us to access. So I'll say Kafka template over here. You can see this is coming in from org.springframework.kafka.core, right? Which is a dependency that we have added. I'm going to say string is the key and string is a value. So this is key value pair. And then I'm going to say Kafka template, like so. Okay. I'll immediately get an error like you need to add a constructor parameter. So I'll get that added over here. Okay. So this is done. And then here, what you need to do is you need to make use of this. Okay. So you need to say Kafka template dot send over here. I'll specify topic name. So I'll say my topic, like so. Okay. And here I can say message, like so. Okay, so whatever message we have over here will be sent to this particular topic, right? And I'll say return message sent, and this is what will be the message. Okay, so I'll say plus message, like so. Okay, so this is the producer that is going to do the job of producing messages, and it is going to send it to this particular topic. Now the time is we need to test this entire thing. So what I'm going to do is I'm going to come over here to my main application file. Let me run this. And let us take a look. Now, before running this, be sure to have your Docker and the Kafka container up and running. So I have started Zookeeper first, and then I've started Kafka. Okay, so be sure to do this and make sure Kafka is up and running, because that is what going to help it connect, because this particular application will connect right over here. So if you come over here, we don't see any sort of logs over here, which should not, so there's no issue as such. Okay, so here we'll come, and here what I've done is I have logged in to the Kafka container. You can see I'm logged in over here using interactive shell, and inside the container I'm running this command, Kafka console consumer topic. I'm listening to my topic over here. Okay, my topic is a topic that is already created. I have and I'm mentioning this bootstrap server over here, and I've mentioned this group, and I'm mentioning from the beginning. So this is something that I've added so that whenever any message is posted, we will see the message over here. And I also have Postman open over here, where I have this Kafka collection created, and here I'll add the request. Okay, I can give this as a request, so I can say producer over here, and I'll post the URL. Okay, not this one, but this one. Yes, so this is the URL, and I'm mentioning post request over here. So if you see over here, okay, we are having localhost 8080 API send, and we have this question mark message is equal to Kafka, hello Kafka. And you can also pass this over here if you add it over here. So if I disable this, you'll see that part go away. If you enable this part come in. So you can add it from here as well. Okay, let me say send over here. Okay, so I'll save this. I'll say send. So it says 200 okay, message has been sent. Now if you come over here to the consumer, you'll see the message is received over here, hello Kafka. I'll send one more, hello, how are you? How are you? Something like this. Let me say send. You can see how are you appear over here. So messages are being sent over here. You can see over here some sort of logs also you will see. You can see producer configuration. Okay, and you can see this entire configuration that is being printed over here. You can see, right? And this was the connection establishment. That is what was printed. And here you are seeing the logs over here. You can see Kafka version being printed, commit ID. Okay, so the messages are being sent, right? And it's working absolutely fine. Like whatever message you send, you will see them appear over here. So if I press this 3 times, and if I come over here, you're going to see 4 messages, right? If I add hello, that will also be posted. Okay, so whatever you post will appear over here, and producer is able to produce the messages now. So I hope this has been useful, and I hope you are able to follow along. So now is the time that we begin setting up the consumer. So what I'm going to do is I'm going to come over to our favorite website, start.spring.io, and I'll start choosing the necessary configuration. So I already have the configuration that we choose for producer. Okay, we have Maven, Java, latest version of Spring Boot. Here, instead of producer, I'll change this to consumer. And you can see the package name and all the other settings reflect accordingly. Jar, Java version 24. And I'll just have these 2 dependencies itself that we had added for producer. I'll just say generate, and I'll download the zip file of this entire project that is generated into the same folder where I have my producer. So I do have downloaded this zip file. You can see consumer.zip. I'll quickly unzip it over here. Okay, extract it over here. And I will delete consumer.zip from here. We don't need the zip file or the zip version. So we have now consumer and the producer, both of them. And I'll head over to IntelliJ. And here in IntelliJ, you will quickly see, so I don't see consumer yet, but I'll right click and I have an option to reload from disk. So you'll see consumer appear. Okay. Now it's not being recognized as a Maven project. So what you can do is you can come over here to Maven. You can say add Maven projects, and you can go to Kafka, consumer, select pom.xml and say OK. Now you can see consumer is being detected as consumer, which is a Maven based project, right? Now what we will do is we'll come over here to main resources and I'll head over to application.properties. I'll change this format first of all to that of YAML. So here I'll just say YAML configuration, and here I'll select all the YAML configuration that we need. Okay, so this is what we need. Okay, this is done. So this is the YAML configuration, and now what we need to do is we need to add some configuration for the consumer over here. Okay, so what I will do is I'll say over here Spring Kafka, I'll say consumer, and I'll say bootstrap servers, and I'll say localhost :9092, like so. Okay, now key spring is duplicated, so I'll just get rid of this over here, and this is the Kafka consumer connection details is what we have specified over here. Now we need to add a consumer that will actually listen to a particular topic, and it will help us get the message that is being posted to that topic. So I'll come over here in the Java code. Here I'll create a new Java class and I'll call this as Kafka consumer over here. Okay, and here I'll mark this as component first of all. So this is Spring managed component, and here I'll say public void. I'll create a method and I'll call this as listen. Okay, it's a method that is being created to listen to messages. And here I'll just say system.out.println received message. Okay, and here I'll just print message. Now we need to make use of an annotation over here. So I'll say Kafka listener. You can see Kafka listener. So this is what I'm going to use, and here you have an option to specify which topic you want to listen to. So I'm going to say topics, and here I can say my topic, and you can also specify the group, but I'm not going to do that. Okay, so let us listen and let us see if we are able to listen successfully to this particular topic, and I'm going to start the consumer application. So let us wait until this consumer starts. So the moment I tried to start consumer, I got this error because port 8080 is already in use. So what I will do is I will have to change the port for consumer. So here I'm going to say server, okay, server port, and I'll say 8081, something like this. Okay, so this is done, and here I'm going to start the consumer now. Let us see if this works fine. And you can see, okay, we get an error over here. What is the error? So you can see the error over here, illegal state exception. There is no group ID that is found, right? So what we will do is we'll add a group ID. That is why the bean creation is failing. So here I'm going to say group ID, and group ID is my new group, something like this. Let me run it now and let us see if this works fine. Okay, so we'll wait for a while, and you can see the group is created and it's joined. Okay, so you can see it's listening to the message over here. Sorry, listening to the topic. You can see. I'll just clear this off. Okay, and I'll come over here. We'll come over here and I'll just post this message, hello. So you can see hello being posted here, and if you come here, you can see received message hello. Right, so it's listening indeed. You can send one more message, hello, how are you, and let me send this, and if you come over here, you can see hello, how are you. So the message is being sent, and you can see how our consumer is listening to all the messages, right? So here we are sending messages to my topic, and consumer is listening to my topic, and producer is sending the message to the same topic itself. So I hope this has been useful, and I hope you are able to follow along. Now let us understand behind the scenes, and for that I'm going to restart both my consumer and the producer. Okay, so we are going to take a look at the logs and we are going to understand as to what is happening. So here, if you scroll up, okay, let me scroll up. There are quite a few logs over here. If you scroll up, you will see that the application has started successfully. Okay, but if you scroll down over here, this is the configuration. So somewhere over here, when the application is started, you can see the application is being initialized. Okay, you can see a few logs at before that, and here you can see the configuration values over here. So you are seeing the consumer configuration that is being printed over here. You can see a lot of stuff like reset. You can see quite a few properties. So this is all the properties with which it is being loaded over here, right? So there are quite a few. If you scroll down, it's never ending. Okay, it's what I guess. So here it ends over here. Okay, the list is very long. Okay, then over here you will also see somewhere Kafka version being printed. So this is the Kafka version that you're working in with. Okay, you can see initializing metrics collector, then Kafka version was printed. Then there is the commit ID. So you can see the commit ID. And then somewhere over here, you will see subscription. So you can see subscribed to topic. So this is the subscription and the confirmation that your consumer is listening to a topic over here. Okay, so that is what you see over here. And if you scroll down a bit, you should also see assignment for the group over here. You can see group related logs over here. You can see. So these are all group related logs, which means that the group is successfully created and assigned. Okay. And then over here, you will see, okay, these are the details over here. So my topic 0, my topic 1, my topic 2. So these are all the partitions within the topic. So this topic has 3 partitions first of all. So this particular group is now assigned to read 3 partitions. It's listening to 3 partitions. That is what it says. Okay, so there is a lot of information is what I mean to say over here in the logs itself. You can see over here, it is setting the offset for partition 2, partition 1 over here, okay, and then partition 0. So it is going through all the partitions, it is connecting to all the partition. Okay, you can see these are all the partitions. Again, it's being printed at the top. Okay, so there are quite a few things that you get to know from the logs itself. For producer, if you go to producer logs, you won't see much over here. Okay, so not a lot of Kafka related stuff. But if you start or if you send a message over here, and if you come over here, you should see quite a few stuff. So if you scroll down, first of all, you can see producer configs. Okay, producer related configuration is what you will see over here. You can see a lot of stuff. Okay, this is the configuration that is being printed. You can see again, it initialized the metrics collector. You can see some Kafka version being printed, commit ID being added, start time in milliseconds. You can see cluster ID, and the producer ID is set to this over here. Okay, so these are the producer logs. Okay, I hope this gives you the clarity. You can take a look at the configuration with which your Kafka consumer is being loaded, and you can take a look at some of the behind the scenes. Now is the time that we begin talking about consumer groups. Now here, if you head over to consumer, our consumer is working perfectly fine. And here, if you go to Kafka consumer, we have this consumer. Okay. And we have only one consumer. So we have the ability over here or the provision to create consumer groups, right? So what I will do is I will first create one more consumer. Okay. So for that, I'm going to just duplicate this method. And yeah, you cannot have same method name. So I'll just say listen 1, listen 2. Okay. Now here I'm creating these multiple consumers in the same file, but ideally in a production grade application in a real world scenario, you will have consumers in different applications on different servers listening and consuming messages. Okay. But for the demonstration purpose, since we are learning, it's okay if we go with this approach where we have multiple consumers in a single file. All right. So here you have this consumer. It is listening to my topic, and this is the group over here. Now, first, let me add this particular consumer to some other group. So I'll assign it to consumer, like my new group new. Okay. Or my new group 1 over here. Okay. Which is not the same group as this consumer. Okay. And here I'll say received message for the first consumer and received message to the second consumer. Okay, So this is how I'm printing. Now what I will do is I'll restart my consumer application. Let me restart and let us see how this behavior works, right? So we'll wait until this application starts. You can see the application has started. Now I'll just clear the console. Let me come over here and let me send a message. So I'll say, hello, how are you? You can see hello, how are you coming in here, right? This latest one is the one that has been produced. And here you can see both the consumers are now printing hello, how are you? Okay. So if I say hello itself, okay, hello Kafka, something like this, you'll see hello Kafka appear over here, okay, onto the console. And here you're going to see hello Kafka being listened by both the consumers. So whatever you are sending in to the topic, it's going to all the consumers that are listening in unique groups. Okay. Now let me move this consumer into the same group. So now you can see the group ID is same for both, right? This is a group ID for the first consumer. This is a group ID for the second consumer. Now let me run this. Okay. Let me run and it's running. And what I will do is I'll just clear the console over here. Okay. This is done. And now let me produce this message, hello Kafka. You'll see hello Kafka being sent once. So this earlier version is the one that I sent sometime back. And this is the one that I sent now. And here you will see only one consumer is listening, hello Kafka. The other consumer is not listening, right? Other consumer did not receive this message. It is listening, but it did not receive this message. Okay, so this is the concept of consumer groups where you can have multiple consumers grouped together and they are functioning as a single unit. So for example, if there are too many messages that are being sent to a particular topic, if the traffic is very high, you can create multiple consumers and add them to the same group so that the consumption is fast and a single consumer is not overwhelmed by the traffic it's receiving. I hope this is making sense and I hope you have been able to follow along. So now is the time that we take a look at topics and understand how topics are created from YAML or from Java code. Okay, so here we have this producer. So here, if you go to producer, we have this Kafka producer that is sending in the message to a particular topic. Okay, now what I will do is let me come over here to the command line. Okay, here I'll stop this. Okay, and here I will run this particular command, Kafka topics -2 times list -2 times bootstrap server localhost 1992. So this will give me the list of all the topics that exist in Kafka. So here you can see there are two topics. One is my topic and another one is new topic over here. Okay. Now you might see one extra topic over here, which I'm not referring to, which is consumer offset. So this is an internal topic that is being created by Kafka itself to manage consumer partition offsets. Okay, so I'm ignoring this one, but these are the two ones that we need to talk about. Okay, so these two I have created. Now let me come over here and let me try sending this message to some topic that does not exist. So I'm sending it to my topic new. Does my topic new exist? No. Okay. Now let me run this and let us see what happens. So let us see if we get any sort of error right now. We don't get. Okay. And let me try to send the message as well. So I'll try to send it. We get 200. Okay. And you can see over here, there is no issue as such over here. Okay. And let me copy this particular topic over here and let me see if we see any sort of warning or message over here. You can see there is no issue as such. Okay. And you can see there is, we don't see any sort of logs around issues. So I'll come over here and let me now try fetch the list of all the topics that are available. So you can see this topic that we sent the message to is automatically created. You can see over here, my topic new. This did not exist initially, but now it's created. Okay. We did not see any sort of error message. Okay. So here what it tells is any topic that you refer to in producer, it will create a new topic for that if that topic does not exist. Now, even though we do not see any sort of error message and this topic is created automatically. Okay, this is not always recommended because there is a setting in Kafka like auto.create.topics.enabled. So if this is set to true, only then you are allowed to create a new topic this way if it does not exist. Okay, but normally in production mode, this won't be the case. Okay, so what I would recommend is if you are planning to send something to a particular topic, you should explicitly get it created. Now, how would you create it? So one way is you create it from here, the command line, or if you don't have access to the command line, you can make use of Java based configuration file, which I will create right now. Okay, so I'll say Kafka topic config. So this is a file that I'm creating, and this file will have the configuration for the new topic that I need. Okay, so I'm going to say configuration over here, and I'm going to say, I'm going to create a bean, and this bean is going to say public, and you can say new topic. So you can see new topic is a class over here. Okay, I'm going to make use of this. I'm going to say create my topic like so. And here I'm going to say return new topic, and you can say you can give the name you want. So you can say my new topic 2, something like this, and you can specify the partition and all the other details. So if you hover on this, you should see topic name, and then you have optional integer, which is number of partitions. Okay, or here take a look at this first one. So this first one says new topic, string name, this is the name of the topic. You have integer number partitions and short replication factor. Okay, so I'm going to say this, and I'll have 3 partitions over here. Okay, and then I can have 1 over here. Okay, so this 1 has to be in short, it will cast it. So you can see now, okay, this is done. Okay, so this is what we are doing, wherein we are mentioning the topic name, the number of partitions, and this is something that we are mentioning, which is replicas. All right, so what I will do is let me now run the producer application. So I'll rerun the producer application, and we'll wait for a while until it finishes the startup. So it's started up, and here let me see if we get any logs over here. So I'll just copy this topic name. Let me see if there is any log. Okay, there's no log. Let me try coming in over here, and let me say, let me list the topics. Okay, you can see this topic being created, my new topic 2. This is what we have mentioned over here, right? And earlier, if you see the earlier command, it was not present, right? We only had these 3, and now we have 4, right? So this is how you can create topics with partition, and you can even describe this particular topic if you want. You can see, so here I have this command. Okay, and you can specify my new topic and then -2, something like this. And the moment you describe, you will see there are 3 partitions over here, right? So yes, this is how you can get your topics created programmatically, as well as using no configuration or YAML configuration. So now is the time that we begin talking about sending objects to a Kafka topic from the producer and consuming that object then via the consumer from that particular topic itself. Okay, so this would involve the concept of serialization and deserialization. Okay, because we are sending in objects. So here, if you head over to this particular file over here, which is Kafka producer, you will see we are sending in a normal string over here. Okay, it's a normal string. We are not making it complex. It's a very simple sort of a sort of a message that we are sending in, right? So what we need to do is we need to now level up this particular piece of code, and we need to set up the producer in such a way that it sends the object to a Kafka topic. So what we are going to do is we are going to simulate a scenario wherein we have this application. This producer is basically an application that is sending in the rider location to Kafka topic, and then there is a consumer that is listening to this rider location. Okay, so you can think of it like a food delivery app wherein one service is keeping a track of or sending in the rider location, and the other service is basically drawing that particular location and displaying it real time. So it's listening to the rider location, right? So this is the kind of scenario that we are going to simulate over here. Okay, so here first of all we are having this post mapping and we are sending in the string. So string is basically an inbuilt data type. So we need to create, first of all, if we want to send in the rider location, we need to create a class that represents the rider location. So I'm going to add a class over here, and this is going to be a new Java class, and I'm going to call this as a rider location. Okay, something like this. Okay, so this is the class, and here I am going to add some bit of code that would represent the rider location. So I'm going to say private string, I'm going to say rider ID like so, and here I'm going to say private double latitude, something like this, and then I'm going to say private double longitude. Okay, a few values over here is what we'll add, and then I'll generate some getters and setters over here. Okay, so I'll say generate getters and setters. You can even make use of Lombok if you don't want to generate getters and setters, but I'm not adding another dependency. I'm just generating it one off. Okay, I'll just add a constructor which is all args constructor. So we have this model or this class setup, right? Now what I'm going to do is here, instead of sending this message, I'm going to create an instance of rider location. So I'm going to say rider location here, and I'm going to create an object over here like so is equal to new rider location, and then I'm going to pass in rider 1 2 3 like so, and I'll pass in the latitude and longitude over here. So the first thing is I'm going to pass in 28.61 and then 77.23 for example, just hypothetical numbers. Okay, so I've added this is the rider location. Let me take this to a new line so that it's a bit more readable, and here I'm sending it to my topic new. Okay, and here I'll send in this location like so. Okay, so I'm sending in this location. Okay, so we get an error over here. You can see required type is string, but this needs the so you need to wrap this as string dot value of. Now I'm getting this because here the type for Kafka template over here, you can see the type is string over here. Okay, so this has to be string and a rider location now because we have added rider location, and this would be string and rider location as well. Okay, so I think this is it. Okay, the error is gone. You can see over here, okay, the error is gone. And what we need to do is we'll print in the rider location. So I'll say location dot to string, something like this. Okay, or you can just say location dot get rider ID. Okay, so I'll just print the rider ID over here. All right, this is done. What I would do is let us test this. So it is sending in this to my topic new. So let us see if we have Kafka up and running. We have Kafka up and running, and we have a listener set as well. So it's set to my topic, but I'll change it to my topic new like so. Okay, so this is done. And then what I will do is let me start the producer. So let us start the producer and let us wait to see how it functions. Okay, so we'll wait until this starts. It started. And now what I will do is I'll just send or trigger this same endpoint which we had earlier. Okay, we had this defined earlier. Now the same endpoint, but we have this message as a request parameter, but we are not making use of this message. Instead, we are creating an object of rider location and we are sending in that location. We are not making use of this message. Okay, so this message is irrelevant right now. Okay, this message is irrelevant right now. Okay, so I'll send this. Let us see what happens. Internal server error expected. Okay, so this was expected. If you scroll up, it has to be some serialization related issue. Okay, yeah, so if you scroll up over here, you'll see Kafka producer 23. So it came on this line, And if you scroll up, you can see over here, class cast exception. Okay, so it is throwing this kind of an error over here. Okay, because it is not able to cast this particular thing. Okay, so there is a string serialization. You can see the serialization related issue can't convert the value of class this to string serializer. Okay, so what is happening is here this object is being sent. Okay, this object is being sent to Kafka topic, right? And this needs to be serialized because it is being sent to Kafka topic. So it is not being serialized right now, and that is why we are getting this kind of an issue. Okay, and earlier we were not getting this issue because we were sending in string, which is easily convertible to byte array, but this cannot be easily converted to byte array since it's an object. So we need to specify serializers. So for that, I'm going to head over to my YAML file. So here in the YAML file for producer, I'm going to come over here, and here we will have to add a couple of serializer, is like I said. Okay, so here and just under producer, I'm going to say serializer over here. Okay, and actually not only serializer, so this will be key serializer. Okay, key hyphen serializer, and then we also need a value serializer, something like this. Okay, and I'll specify org dot apache dot kafka dot common dot serialization dot string serializer. So this is a serializer that we are using for key. Okay, so key is being serialized as string, right? And for the value, basically, so value is an object, so it has to be serialized using JSON serializer. So I'll just remove this string, and instead of this, I'll make use of JSON serializer, which exists in org dot not Apache. So this will be Spring Framework dot Kafka dot, instead of common, it will be support dot serializer over here, something like this. Okay, so org dot Spring Framework dot Kafka dot support. Okay, so I missed a G over here. Be sure of not making any sort of spelling mistakes over here. Okay, org Spring Framework Kafka support serializer and JSON serializer, and this is org Apache Kafka common serialization dot Spring serializer. Okay, string serializer, and then I'll just hit restart on my producer application. So we'll wait for a while until the application starts. Once it starts, what I will do is I'll come over here. Let me send this again. You can see now the message is sent, and you can see rider 123 being printed over here. Okay, so you can see over here it's sent, everything is successful. Let us check our listener if we are able to see the object. You can see we are able to see the object. So this was the object that we sent, right? You can see rider ID, rider 123, 2861 and 7723. So this is working absolutely okay. We are able to send an object with the help of serialization to Kafka. Now let us head over. So this is about producer, wherein what we did, let's review the steps. So first of all, we added an object. So we decided we want to send an object to Kafka. So we created a class that represents the object. Then in the producer, where we were producing the message, I actually modified and tweaked that particular endpoint to create an object of the class that I created and then send the object over to Kafka. I modified the Kafka template to represent rider location, and I modified the initialization to do so. And then in the application YAML, I specified the key and value serializer. This was important because I wish to specify how the values are serialized. This is done, and then I could successfully see message being sent. Now let us head over to consumer and let us tweak our consumer in a way that it can consume objects. So for that, I'll head over to our consumer application over here. I'll collapse everything in the producer. Let us go to consumer and let us see what we have over there. Okay, so here in the consumer application, Kafka consumer, you can see we are consuming, there are a couple of consumers and we are consuming the message. So I'll create one more consumer over here. Okay, I'll just paste it over here, something like this. I'll say my topic new is what we are listening to. Okay, my new group, and I'll say rider over here. This is a absolutely new group that I'm creating that is being associated over here. Okay, and then what we need to do is we need to consume So instead of listen1, I'll say listen to rider location over here. I can call this method whatever I want to. And here, instead of string message, you will say rider location. Now, rider location, of course, does not exist. So what I will do is I'll just copy this entire file that we had created in producer, and I'll simply paste it over here in the consumer package. Okay. So this is added now over here. Okay. This file. And now ideally it should not give any sort of errors over here. Rider location, and I'll say location over here. Okay. And here I'll say received location. Okay. And here what I can do is I can print in the location. So I'll say rider, okay, sorry, not rider, location dot get rider ID. Okay. And I'll say create something like this, and I'll say location, or 1 second, let me take this to a new line. I'll say location dot get latitude, and then okay, location dot get longitude. Okay, this is done. So this is done, and now one more thing, we need to add serializers in the consumers as well, otherwise it is not going to work and it is going to fail. Okay, so I'll come over here quickly, and under consumer I'll add these two serializers. So key is being serialized as string. Okay, it is making use of string serializer, and value is being serialized as JSON over here using JSON serializer mentioned over here. All right, I don't think we need to do any other kind of setup over here. Okay, and let me start the consumer as well. So I'll start the consumer. Let us see if we are able to see the response. Okay, so do we see anything? Nothing yet. Okay, nothing yet, nothing. So let me send a message here. So I'll come to Postman and I'll send in a message. So here, if you see, we get this message conversion exception. Okay, so what this means is we probably have received the object here, but we are not able to convert it. Okay, so here, if you see, let me scroll up. It's listening to this topic. Okay, you can see the payload over here. So we are receiving the object details over here, right? We are receiving the object details, but somehow the conversion is not happening. And for that, I believe we'll have to add some more properties. So first of all, we have added the property of serializer over here, which we copied from producer in the consumer. But here actually we'll modify this to deserializer. I'll say deserialize. And here also, instead of string deserializer, string serializer, I'll say string deserializer, something like this. Okay. And here, instead of JSON serializer, I'll say error handling deserializer, something like this. Okay. And here I'll add additional properties, something like this. And I'll say string dot deserializer dot value dot delegate dot class. Okay, and I'll say org dot spring framework dot Kafka dot support dot serializer. So this is the class, and I'll map this to JSON deserializer, something like this. Okay, this is done. Now I'll say spring dot JSON dot trusted dot packages. Okay, so I'll mark the trusted packages over here. So I'll say all the packages are trusted, because you can even specify the package location over here if you want to mark specific packages as trusted one. But here then I'll say value dot default dot type. Now what is the type of the object that we are receiving? We are receiving comm dot demo dot consumer dot rider location type object. Okay, this is what we are receiving. Okay, now this is done, and I will come over here. I'll add one property in the producer as well. Okay, so in producer, I will simply say that I don't want type headers. Okay, so there is something called as type headers. I don't want to pass in type header with my object that is being passed in. Okay, so here I'll add additional properties. I'll say properties colon. I'll say spring dot JSON dot add dot type headers dot false. Sorry, colon false. So this we are adding because we don't want the type header. So this object that is being produced is of type com.demo.producer. So this is a package com.demo.producer.write location, right? That is a type. So we are not sending in the type over here in the headers, okay, because this might even cause the issue. So I'm adding that, and here I have added these properties. So whenever you, so I'll just add one more line of explanation. Whenever you send object, there is something called as type ID that is being added in the header, okay, to tell consumer what Java class message is. So that is something that we are disabling, okay. And here, what I've done is I've added some more properties over here. We'll go through each one of them. Okay, so here first of all I have specified the key deserializer, okay, and this says that this message this has to be serialized or deserialized as a string over here. Okay, so this is first part. Then we have the value deserializer over here. Okay, and this value deserializer is this is basically being deserialized as error handling deserializer, and we are doing this because it catches decentralization errors and gives you a chance to handle them more gracefully. So that is what I'm doing over here. Okay, then I have some additional properties over here wherein I am making use of this deserializer over here. If you see JSON deserializer, okay, so since we are making use of error handling deserializer here in the beginning, okay, we need to tell which real deserializer it should delegate it to. So we are specifying the real deserializer over here as JSON deserializer, okay, because we are working with JSON messages. And in the next line, we are specifying the trusted packages. So we want all the packages to be trusted, right? You can specify the packages if you want only specific packages to be there, okay, and it tells Spring which packages are trusted for deserialization basically, right? And then you have this over here where you are mentioning the you're telling the consumer that, hey, always try to convert incoming JSON messages to rider location class from com.demo.consumer package. That is what we are telling. Okay, now let me rerun this application, both the sides, the producer and the consumer as well. So I'll restart and let us see if this works absolutely okay. Okay, so the producer should be up. Let me send the message. Message is gone. If you come over here to consumer, okay, you still get the error. What is the error now? Okay, so the error now says, it's very clear, there is no default constructor in rider location. So it needs default constructor to deserialize, right? So I'll go to consumer, and here in the consumer, I'll go to rider location. I'll just add a default constructor. So constructor, say none, restart the consumer. Let me produce one more message. Okay, I've sent one more message already, and you should see that message being printed once this starts. So you can see received location. So the message is produced and the message was sent and it is received over here. You can see if I send 5, 10 more over here, you can see all the messages will come over here. Okay, so I actually hit cancel, I believe. So you should, let me send a few more. So if you click this quickly, you can see this button changes to cancel. So none of the requests were sent. But now there are so many requests sent. You can see all the messages are being sent and they're also being received here on the terminal. So this is working fine. There were quite a few tweaks we did, but in the end, we have this entire setup working. So I hope you have been able to follow along, and I hope this has been helpful. So now is the time that we begin talking about the functional interface. So what is a functional interface as a concept in Java? So functional interface, first of all, in Java is an interface like the interfaces that we create. But this interface just has exactly one abstract method. So here you can see one functional interface that I have as an example. So here you can see this interface is called my interface, and I have one abstract method which is void do something, and this do something is just some example, but you can have something like uppercase, lowercase, or something like that, right? Now, the main purpose of the functional interface is to be used in Lambda expression, method references, and they provide a way to achieve functional programming in Java, right? So this is what functional interface is in a nutshell. And this feature of functional interface was introduced in the later version of Java, okay, when functional programming started picking up. So that's functional interface. I hope this is making sense. This is the simplest definition possible, right? Now, there are a few functional interfaces that exist that are pre-built in Java library. Now, of course, you can define your own functional interface as well using the annotation that I showed you at the rate functional interface. But there are a few functional interfaces that exist, and these exist in the Java library. Okay, so these are the ones that I've listed over here: function, consumer, predicate, and supplier. Okay, now let us talk about each one of them. So first we'll talk about function. So what is a function? So function takes an input of type T and returns something of type R. So this is a syntax over here. You can see the syntax. So the syntax is function, string, integer. So string is the input and integer is the return type. You have getLength, which is the function name over here. And then you have this over here, the syntax over here, which is a lambda-like syntax. And it is returning the length over here. So this is the function, and you can make use of this in this way. So you can say system.println getLength.apply hello. Okay, so getLength is being applied to this particular string, which is hello, and this is being passed over here as string. So this is how it is being used. Okay, so this is one way, or this is one built-in interface, functional interface. Another one we have is consumer. Now what is consumer? So consumer takes input of type T, does something, but returns nothing. So it does not have anything that will return. Okay, so it will consume your input and it will do something with it without returning anything. So here I have an example. I have consumer string, which is printer, and I'm saying S. So I'm creating this lambda-like syntax over here and I'm printing it. So consumer is normally used when you want to print something or log something like that, but you want a parameter as well. Okay, and you can see over here, printer.accept is how you can use it, and you can pass in the parameter over here. So it prints this message, hello world. Okay, so this is consumer. Then you have supplier. Now supplier takes no inputs, but returns a value of type T. So you can create supplier this way. So you can say supplier string, give message, and it will return this hello from supplier. So you can see over here, give message.get is how you use it. Okay, this is supplier for you. So it will just supply you with a value or something, right? This is supplier. Then you have predicate. Now predicate takes the input, okay, over here, and it returns either true or false. So you can see over here, it is taking string over here is long, and it is returning true or false. So whether this string is greater than the length of 5 or not. You can see over here, this is how you can make use of it. So it basically returns a Boolean value is what I mean to say over here. Okay. So these are some inbuilt functional interfaces that exist. These are also known as functions. I hope you were able to follow along, and I hope this has been useful. It's time that we talk about Spring Cloud Function and understand what it is. So Spring Cloud Function is a Spring project that lets you write one Java function, which is a supplier, a function, or a consumer. And then you can bind that particular function to HTTP, or you can bind it to message broker like Kafka, RabbitMQ, or to a Lambda by configuration alone. So understand this. Whenever you have to make or build a REST API, what would you do? Right? So you would first create a controller, you would create a service layer, and let's say you just want a simple REST API that is going to return uppercase of whatever input is provided. It's that simple, right? Now for this simple code, you will start writing controllers, service layer, and all of that. Okay, there is a lot of boilerplate code that comes into picture, right? And there is a little bit of maintenance pain and duplication as well, right? So with Spring Cloud Function, what happens is you just create one Java function like a supplier or a function or a consumer, and you write the logic within it, and you make use of this project, which is the Spring Cloud based project. And what this will do is it will expose it over to HTTP or Kafka or Lambda just by configuration. So you have to do some sort of configuration in the application properties or YAML file, and then the API will be exposed. So like in our example that we were talking about, wherein I said like you want to create an API to just expose or return the uppercase of whatever input is provided. So in that case, you have to just do some configuration in the YAML file or application.properties file to just expose the function over the HTTP endpoint, and it will just do so. So you don't need controllers, you don't need anything. You just need this dependency, and you just do one configuration, a simple one, and then you have the REST API available. So that is how it works. So let us head over to browser over here, and here in the browser I am on spring.io, which is the official website. And here if you go to projects, you'll see a lot of Spring based projects. So we'll select Spring Cloud because we are talking about Spring Cloud function. So this has to be a part of Spring Cloud project, and here under this project you'll see this project which is Spring Cloud function. So if you select this, you will see over here, you can read, okay, it says it's a project with these high level goals. Okay, it will promote the implementation of business logic via functions. Okay, it will decouple the development lifecycle. Okay, so there are quite a few things that are mentioned over here. You can see it is also used to enable Spring Boot features like auto configuration, dependency injection, metrics on serverless provider. So it's indeed a useful project. Okay, you can see over here there are a few features. You can just go over here and read a bit, and you can see this is the function that is being created and being exposed. You can see this is a Spring Boot application. Okay, so this is here is a complete executable. So you can see over here, here's a complete executable testable Spring Boot application implementing a simple string manipulation. What is happening? It is simply returning uppercase over here. Like whatever input you give, it is returning uppercase. And you can see over here, we are making use of this functional interface, which is function, right? And is coming in from java.util.functions package. And it is being exposed over REST API, right? This is what it is. You can go through this. You can come over here and you can go to learn. And here you will find the reference documentation as well, which you can refer to just in case if you wish to see. Okay, so you can see the programming model, the standalone web applications, you can see. Okay, so these are, so you can just go through this. I hope I've made a point and explained to you as to what Spring Cloud function project is and how it makes sense to use it today. Okay, so you just define a function and you can bind that function to HTTP request. You can bind it to Kafka, or you can bind it, or you can have it as a serverless function. You can use it in multiple environments, okay, without having the need of defining things like the boilerplate code, like controllers, service layers, and all of that. You just create one function and just specify the configuration, just include this project as a dependency, and things are done. That is it, right? So I hope you understand the power of this project and how useful this can be, right? I hope this has been useful so far. So now is the time that we go hands-on with Spring Cloud functions, and for the same, I'm here on Spring Initializer website because we are going to play a bit and take a look at the dependencies that we need to add. Now, one thing I would like to tell over here, you can create a new project by selecting the dependencies that I'm going to show you. Or if you have an already existing project, you can try this out in an already existing project. So I'm going to play around with the already existing project itself, right? So what I'm going to do is here in Spring Initializer, I'll select Maven, Java, latest version of Spring Boot. I'm not changing or making any sort of changes or updates to project metadata that you see over here. Okay. And the reason for this is because I am not creating a new project, but instead I am making use of an existing project that I have. So this is something that we'll leave as is. I'll come over here. In dependencies, I'll come over here and I'll search for Spring Cloud functions, or you can just search for function and you'll see this come in. This is a dependency. So it says promotes the implementation of business logic via functions and supports a uniform programming model across serverless providers, as well as the ability to run standalone. Right? So I'll just select this and we'll see what all dependencies we get with this. So if you go to explore and if you scroll down, you'll see you get Spring Boot starter and you get Spring Cloud function context. Okay. Now what I will do is we'll come over here to our project. So this is our project, and here in the producer, I'm going to, I'll add the dependency in producer, and here in pom.xml, if you scroll down, okay, so you will see I have dependencies like web over here. This web is already added, and starter is already added. Starter test, Kafka test. So these things are already added. I don't need starter and all, but I need web over here, right? So web is added. So why I'm concerned about web, why I'm checking about web, because I'm going to create a Spring Cloud function and expose it as a REST API, right? So I'll come over here. I'll just copy this function context. I'll also copy this Spring Boot starter. Come over here and let us just paste this. Okay, so this is done. I'll just do a Maven reload to get all the changes onto my local system. Okay, now this is done. Now what I will do is, once this is done, I will head over to the class over here and I'll add a new class. Okay, now what is the class that I'll add? I'll create a new class calling function class, something like this. Okay, and here, or I'll rename it to functions, and I'll say rename file. Okay, so it's functions. Okay, so one more thing over here, one more problem happened, which I didn't pay attention to, is we did not find this dependency. So here, so I'll tell you what happened. Okay, we don't have Spring Cloud configured here. Okay, we don't have Spring Cloud. So I'll better get that. To get Spring Cloud is you need to add this dependency management between dependencies and build. So if you come over here, between dependencies and build, you don't have dependency management, and you need to add Spring Cloud version over here in properties. Okay, so there is Spring Cloud version in properties. So I'll first copy this dependency management. I'll add it in dependencies after dependency over here, and oops, so this got copied. So I'll just copy this over here. Okay, this is done, and then I'll add this Spring Cloud version like so. This will be added in properties like so. Okay, and then I'll do a Maven reload. Let us see if this works. This should work ideally because we have added the Spring Cloud dependencies. So this is a part of Spring Cloud project, right? So Spring Cloud is important. So to add Spring Cloud, you can add this, and then after dependencies, you need to add this dependency management between dependencies and build. If you don't want to, if you feel this is a bit, editing this XML is a bit challenging, you can just recreate the XML by entering the details. So you will see all the details over here, like group ID, artifact ID, the name, the description, everything you will see over here. Just enter all of that over here and just get it regenerated. Okay, you can enter all of that here in project metadata, add all the dependencies and get it regenerated. That is one way to do it. So this is done. I have this class also created, which I was working on, which is functions class. And here we'll start defining the functions. Now I'll say, first thing, I'll mark this as configuration because we want Spring to manage this class. Okay, I'll create a bean over here and I'll say public function. Oops, not function class. I'll say function. This one, which is coming in from java.util.function. And I'll say the input type is string and the return type is string. So we'll create a very simple function that will just return the uppercase of whatever value we provide. So I'll say uppercase, something like this. And here I'm going to say return value, and I'll say value dot to uppercase. Okay, to uppercase, something like this. Okay, I'm getting a warning. So this is a lambda can be replaced with method reference. You can do so if you want to. Okay, but I'll stick to this. It's totally your choice. Just the syntax changes. Okay, you'll make use of method references instead of this lambda. Okay, so this is done. What we are doing is we are creating this function class, which is having all the functions that we need. And I've added this function over here, which is the uppercase function. And the job of this function is to give us the uppercase of whatever value we pass in. So this is done. Now what we need to do is we need to add a configuration for this particular function that we added. So I'll come over here to application.yaml. Okay, here we have few configurations for Kafka and all, but here I'm going to add the Spring Cloud function related configuration. So I'm going to say Spring. I'll get an error for Spring, like a red underline, because this key is duplicated. That's absolutely okay. I'll ignore it for a while. Okay, I'll fix it in a bit. And here I'm going to say cloud function. I'll say definition, and I'll mention the function name over here. Okay, this is a function that I want to be exposed. And then I'm going to say function dot web dot path. I'll say slash uppercase. So what I'm doing is I am making this function, which is uppercase, exposed. I'm exposing this function at this endpoint. Okay, that is what I am doing. Okay, now this is done. Now what we need to do is we need to make a call to this particular function. So now once this is done, what I would do is I would just get rid of the Spring over here. The error goes away, and this is now a part of this parent key. Okay, so this is done. Now let us run this application. So what I'm going to do is I'll make sure that Kafka is up and running, because this application also needs Kafka. But if you have created a new application that is not dependent on Kafka, okay, so this I already had an application which was producing messages for Kafka. Okay, and that is why I have to keep Kafka on so that it connects to Kafka. But if you have created a new project from here, okay, and you have downloaded a new project and you have set up completely new without Kafka dependency, you don't need Kafka. But if you have this dependency and if you have modified existing project, you need Kafka. So just evaluate that at your end, and just make sure that the application is started. Okay. Now once the application is started, you would see the application is up and running, no errors as such. Now I'll come over to Postman. In Postman, I will add a new request over here, HTTP request. And here I'll select post. I'll say localhost, and here instead of hello, okay, instead of hello, I'll say uppercase. Okay, this is the endpoint, uppercase. And here in the body, I am going to pass in raw, and I'll pass in hello, something like this. Okay. So you add hello this way, okay, and try sending it. Okay, so we get this error over here. Let us see what the error is. So everything is fine. This also looks fine. Pom.xml is also fine. Okay, so it's probably because we have missed one dependency. So let us try adding that dependency. So here we have this Spring Cloud function context dependency. We would also need, so I'll just do copy paste of this Spring Cloud context, Spring Cloud function context. So I'll say Spring Cloud starter over here, and function instead of context, I'll say web over here. Okay, something like this. So you get this suggestion. Okay, so this is what we need. Okay, so just duplicate this one, just duplicate this thing, and just add this Spring Cloud starter function web. Okay, so I realized, like, to expose a Spring Cloud function over HTTP, you need this as well. Okay, and then do a Maven reload over here. Now, if you're adding this, you don't need basically the web dependency, this one. Okay, so I believe if you just add this, and just add the starter, these three things, I think your Spring Boot function should be exposed over web. Okay, I've done a Maven reload, and what we will do is we'll just restart the application. Okay, I'm not removing this web dependency. Okay, so if you come over here, this web dependency I'm not removing. These three is what I've added, and these three is what we need. Okay, this web dependency I'm not removing because it was there already, and it might break some functionality in the existing project, so I'm not touching it. Okay, this is started. Come over here and just try sending in the request, and now you can see hello as the output. Okay, you can say hi over here, send it. You can see hi. If you say what's up, okay, whatever you send, okay, you will get the response. You can see, and everything is being converted to uppercase. Now, what did you do to expose this endpoint? You literally did nothing. Okay, nothing is too much. Okay, you did something, but you added a bit of configuration and you added one function. That is it. That is what you did. You did not create controllers. You did not create service layer. You did not create all of that. So a lot of boilerplate code is just trimmed out. Okay, and this is an amazing Spring based project. Okay, Spring Cloud Function is what I'm talking about. Spring Cloud Function is an amazing Spring project, because if you want a simple service, earlier what used to happen is, if you want a simple service like sending notification, right, or sending an email service. Now for that service, you have to write controllers, service layers, you have to write repository, all of this. So a lot of boilerplate code and setup related work used to be there. Now with Spring Cloud Functions, what you need to do is, for this email sending service, you don't need a REST API, right? So you can just add a function which accepts the parameter and it just does the job over there. And this function is exposed over REST API just with minimal code. So it becomes a lot easier. And instead of function here, we are returning a response. Like here, it is returning a value over here. If you don't need a value, you can make use of consumer or supplier, whatever matches your use case, right? And it has to come in from this package, this java.util.function. So isn't this amazing? What do you think about this? So I believe this is amazing, and I'm sure you are so excited to use it in your Spring Boot based projects, because this unlocks a lot of possibilities and it makes your life much more easier if you understand how to make right use of it. Okay, you just need to remember all the dependencies that you need and the configuration that you need and how to create or make use of function over here from like functional interfaces that exist in java.util.function. Okay, so I hope this has been useful and I hope you have been able to follow along. So now's the time that we begin talking about Spring Cloud Streams and understand what it is. So Spring Cloud Stream is a lightweight framework which is a part of Spring Cloud project, and it is used for building event-driven microservices. And what it does is, what value it provides is, it lets you write plain Java functions, which means you can create, you can make use of suppliers, function, consumer that exist, and then you can bind them to messaging destinations like topics, queues, without writing any sort of broker specific code. So I hope this is making sense, So let me give you a better explanation, or let me go a little step further. Okay, so if you're writing a service that has to communicate, like consume or produce message from a message broker, you will have to write broker specific code. Now if you're making use of RabbitMQ, you will have to make use of RabbitMQ based classes in your code so that you can send and consume the messages. If you're making use of message broker like Kafka, you have to make use of Kafka based classes within your code so that you can consume and send messages to and fro from Kafka, right? That is how things work, right? So you're making use of, the point over here I'm trying to make is, you're making use of broker specific code, which is broker specific classes, right? And tomorrow, if the messaging broker changes, for example, if your application or your company decides to switch to Kafka instead of RabbitMQ, then you have to rewrite all the code. You have to see where all RabbitMQ specific code is written, and you have to go to that file and make changes, right? And this is a little bit cumbersome. So what Spring Cloud Stream does is, it abstracts and it allows you to basically write code for messaging destinations like RabbitMQ and Kafka without writing broker specific code. So the code that you write is generic, and tomorrow if you switch the broker, like from Kafka to RabbitMQ, or if you switch the provider, you don't have to make any changes into your code. You just have to make some changes in the configuration. That is it. So that's the benefit it provides. So if I have to explain this with the help of a diagram, I would showcase some diagram like this. So you can see over here, you have like a Spring Boot application, and Spring Boot application would communicate to RabbitMQ or Kafka usually. Now Spring Cloud Stream sits in between, and it basically makes sure that you don't have broker specific code in Spring Boot application. So a Spring Boot application is not going to write any sort of broker specific code, and whatever happens, like if you switch from RabbitMQ to Kafka or Kafka to RabbitMQ, or if you use both, it is going to allow that, and you can make use of that with the help of Spring Cloud Stream, right? So basically it sits on top of messaging middlewares via binders. So there are binders and it abstracts everything for you, and it makes your life much more easier as a developer. Okay. So that's the benefit that Spring Cloud Streams provide. And I'll take you to the browser. We'll take a look at the project. So here I am on spring.io, which is the official website of Spring. Come over here under project and just go to Spring Cloud over here. Under Spring Cloud, you will find this project over here, which is Spring Cloud Stream. This is the one. Select that and you will see over here, it's a framework for building highly scalable, event-driven microservices connected with shared messaging systems. Okay. It provides a flexible programming model built on already established and familiar Spring idioms and best practices. Okay, so this is what it is, and you can see it supports these all binder implementations. So it supports RabbitMQ, Kafka, Streams, Pulsar, Amazon, Kinesis, a lot of stuff you can see. So whichever you're using, you can make sure you use Streams over here. And you can see over here, these are all the details of Spring Cloud Stream over here. Okay, so this is what happens. And now you can go to learn over here, and you can also take a look at the reference doc that exists for a particular version. Okay, so you can just go through this reference doc, and you can see how the things work. So I hope things are clear, and I hope you have understood the significance of Spring Cloud Stream. Now, Spring Cloud Stream, I'll mention one point over here. It makes use of Spring Cloud function to bind to the message broker. Okay, so this is something that you will see in action when you start making use of Spring Cloud Stream. All right. But for now, I hope the significance of Spring Cloud Stream is clear as to why this project exists and what value it provides. I hope this has been useful. So now it's time that we transition our project to Spring Cloud Stream. And for this, what I'm going to do is I'm going to start with producer, and we'll start producing messages that we send to Spring Cloud Stream. So we will begin with the pom.xml file in the producer. So what all changes we'll need is we'll need some changes in the dependencies. Then we'll head over to writing Java code, wherein we'll create a way, or we'll define a way which sends in some data at regular intervals to a Kafka topic. And then we are also going to configure, like do some bit of configuration in the YAML file. Okay, so let's go step by step. So I'll first open up this file over here, which is pom.xml. Okay, or pom.xml, I'm sorry. So it's Maven is what I'm using. Okay, now if you see over here, there are quite a few dependencies that I already have, like Spring Boot Starter. I have Spring Cloud Function Context. We also have Spring Boot Starter Web over here because we're making use of APIs. And then I have Kafka related dependencies because we are connecting to Kafka. Okay, so what I will do is I'll keep things simple. I'll also minimize the number of dependencies that we need. All right. So first thing is we need Spring Boot Starter. So I'll leave this part as is. Okay. And then we need Spring Cloud Stream related dependency. Okay. So what I will do is I'll press enter a bit. I'll copy this entire thing. I'll paste it over here. Okay. Spring Cloud, instead of function context, I'll just get rid of this over here, and I'll say stream over here. So you can see this stream. Okay, so this is what I'm adding, and you can see Spring Cloud is already added. So it's part of Spring Cloud project. Okay, so Spring Cloud Stream is added, and then I also need a binder for Kafka. Okay, so we'll talk about what binder is, why we need this dependency, but I'll get rid of Spring and I'll say Cloud Stream. So you can see binder Kafka. This is what I need over here. Okay, so I've added this. This is done. And I also need one more dependency. Okay, this is going to be around Jackson. Okay, so I'll say faster XML dot Jackson dot core over here. Okay, and then I will come over here and I'll get rid of this. I'll say Jackson, JACKSON, Jackson data bind over here. Okay, I think this is it. This is what we need. Okay, so let us go through this, but before that I will just comment out the rest over here. Okay, so let me take a look at all the dependencies until here. Okay, so these all dependencies were present early on. I'll just comment this out. Everything is commented, and I'll just do a Maven reload. Let us see if we are able to get all the dependencies locally without any errors. Okay, so it's resolving all the dependencies for producer, as you can see. Okay, so this is a problem over here. So it says it's not able to find this dependency, and there's a problem. So instead of org dot, this will be comm. Okay, so you can see now comm dot faster XML dot Jackson dot core. Okay, so that is why it was not giving you auto suggest. Okay, so that was one red flag. Okay, but yeah, this is the dependency that we have, and I'll just do a Maven reload over here. Let us see if this works. So it's done. Okay, now let us go through why we need each of these. Okay, so first is Spring Boot Starter. Goes without saying, this gives you the basic power of a Spring Boot application, like auto configuration, starters, ability to run the app without with main method, and all of that. Okay, then we have Spring Cloud Stream. Now this gives you a way to create event-driven application, and we don't have to worry about low-level stuff like RabbitMQ, Kafka. So I don't need to write the Kafka specific code or RabbitMQ related code in my application if I'm making use of Stream over here. So I've added this, okay, because I'm moving to Spring Cloud Stream. Then I have this dependency, which is binder Kafka over here under Stream. Okay, so this connects your application to Kafka under the hood, and it understands that when you call a function, the message should go to a Kafka topic. So that binding is created with this dependency. Now I'll tell you something. If you are not making use of Kafka, if you are making use of RabbitMQ, so if I get rid of this, okay, and if you see over here you also have Rabbit related dependency. So this is for RabbitMQ. So you can see Spring Cloud Stream binder Kafka, Spring Cloud Stream binder Rabbit. So if you're making use of RabbitMQ, you have to make use of Rabbit over here. But I'm making use of Kafka, so I'll just do Control Z, and here we have Kafka. Okay, so this is going to bind to Kafka over here, or to a Kafka topic. Okay, and then we have this dependency. Okay, so this will help us convert our Java object, which is rider location, into JSON format, because Kafka topics usually expect text, which can be in JSON form, and not Java objects directly. So that is what we need. So this is all the dependencies that we are going to need. Okay, I hope this is making sense. Okay, now I'll come over here, and here I will head over to producer. Okay, now we'll see all sort of red marks over here, because we have removed quite a few dependencies, right? We removed the web related dependency as well. So this is going to throw errors all over. Okay, so what I can do over here is I can have this code over here, and I can create a new producer, and I can comment this entire thing out. So let me copy this over here, and let me paste this over here. So I'll say producer streams, something like this. Okay, I've added this, and I'll just do a cleanup in this new file. Okay, I don't need all of this. Just get rid of this. I don't even need this thing over here. Like, I'll get rid of this. Okay, and we will remove these methods. Okay, so this is what we are removing. This is Kafka specific code. We are making use of Kafka template, right? So this is Kafka specific code over here. So I'll get rid of this also. And we don't need Kafka template as well, so we can get rid of that also. Okay, so we'll just optimize imports. We now have an empty file, right? So without Kafka specific code, we are going to send data to the topic. Let us see how. And before that, I will just comment this entire file out. Okay, just comment this entire thing out. I'll just uncomment this first line for package, and I've commented this entire file out because it was throwing all errors, because we have got rid of of the dependencies, right? So I'm just closing this, and now we have Kafka producer streams.java, which is a new file where we will be writing in our code. Okay, now I'm going to make use of functions over here. So I'm going to create a supplier. Okay, and this supplier is going to send rider location to a Kafka topic. Okay, so I'm going to say bean over here. It is going to be defined as a bean. I'll say public supplier over here, and here I'm going to say rider location like so, and I'm going to say send rider location over here, something like this, and here. Okay, let me collapse this so that you have a better view. So here you are going to say return. So I'm going to return, and I'm going to have the definition over here. So I'm going to say rider location. Okay, and I'm going to say location is equal to new rider location, and the rider location is rider 1 2 3, and location I can have 16,7, something like that. And this is the latitude. The longitude I can have 88,2. Like these are just random latitude and longitude. Don't go on the web to search for what are these or what is the location for these latitude and longitude. Okay, I'll just have a system.out.println statement. I'll say sending, and here I'll say location dot get rider ID. Okay, this is done, and now over here I'm going to return the location over here. Okay, so this is done. But the thing is, where is this data being returned, right? Or where is this data being sent? Okay, so to which Kafka topic? Okay, one more thing, I'm seeing a red mark over here. It's probably because I've missed a semicolon. So I'll add a semicolon and the issue is gone. Okay, so the configuration stuff for the Kafka and where this particular thing goes in, that is really important. Okay, and that is something we are going to have in the YAML file. So YAML is going to decide and define where to send the data and how it is supposed to be sent. Okay, so what I will do is I'll keep this file open. I'll head over to resources, application.yaml file. Here also I have quite a few code written. Okay, so I'll just comment this out, this entire thing. Okay, I'll just have the application name and we'll start from scratch over here. Okay, so I'll say cloud, I'll say function over here, and I'll say definition. What is the definition? Send rider location. Why send rider location? Because this is the name of the function over here. Okay, this is done. So it is making use of Spring Cloud functions, as you can see over here. Okay, now what I'm going to have is I'm going to have Spring Cloud stream as well over here, and I'm going to say function definition, and I'm going to say send rider location over here. Okay, and then I'm going to have bindings. So at the function level, I'm going to say bindings, and I'm going to say send rider location. So this is the name of the function. I'm going to say dot out. Okay, and I'm going to say 0. Now why are we doing this? So we are saying like whatever is the output of send rider location function, which is the function over here. Okay, send it to a particular Kafka topic, and we'll be defining the Kafka topic over here. So I'll just add this. I'll say destination colon, and I can say my topic new, something like that. You can have a topic created over here, and you can also specify content type over here. I can say application / JSON, something like this. Okay, so this is done, and so this is done, and what we need is we need one more thing over here. So we need to have Kafka related bindings as well. Okay, so here, where is the Kafka related bindings? Okay, there is no Kafka related bindings, which means we need to specify the broker or where Kafka resides. And here I'm going to say Kafka. Okay, just under stream over here. Okay, I'm going to say Kafka, and then here I'm going to say binders, and then here I'm going to say brokers, and here I'm going to say localhost colon 9092. So let me explain this a bit to you. Okay, so what we are doing is we have this application with this name. Okay, and then we are specifying the function definition over here. Okay, so this tells Spring which function we are using. In our case, it's send rider location. Okay, and then here we are defining the same thing like we did. Here we defined for Spring Cloud function. Okay, and we are telling here like which cloud function we are using. And then here we are doing from the same thing from the stream side. Okay. And both are written over here for clarity purpose. Okay. So here I've mentioned this, and then over here I am binding the output that we are getting from this particular function. I'm saying .out 0, and I am sending it to this particular destination, which is my topic, and I'm sending it as application as JSON type. Okay, so what I'm saying over here is with this line, I am telling Spring to convert Java object into JSON text before sending it to Kafka. Okay, and here I've defined the Kafka address. Okay, so this tells my application as to where the Kafka server is running. Okay, now here what I've done is I've started Docker. Within Docker, I have Kafka and Zookeeper up and running. Okay, so just make sure you have done this, and I have logged in using bash into Kafka container, and here I am listening to this topic, which is my topic new, and seeing if the response is being generated or the data is being generated from here. Now we'll run this. So I'll come over here and I'll say run, and let us observe as to what happens. So do we see any sort of errors? So before running this, make sure you have like you have done a Gradle sync or a Maven sync over here. Okay. So what is happening? Are we seeing anything? Okay, so we are not seeing any sort of messages being produced here yet. So I was not seeing the output. So what I did is I just rebuilt the project over here from menu. If you see rebuild, and I started seeing this these errors. Okay, in the test package. Okay, and I'm getting this error because I have commented out the test related dependency. So this dependency of not this one, this Spring starter test is being commented out. So I'll add this. Okay, let me do oops. So I'll get an error, of course, because I'm also copying the commented code. So I got it cleaned. Okay, there were some unwanted comment characters. Okay, so I'm just doing a Maven reload over here. Let me also rebuild the entire project. Okay, let me rebuild the project. So you can see it's rebuilding, done, and let me restart the application now, and let us see what the output looks like. Okay, so it's rejoining the group. It's rejoined. So it's still not producing messages. Let me check over here. Okay, so one problem could be is because this bean or this supplier is not in a Spring managed class or a configuration class. So I'll just mark this as a configuration, and taking a look at YAML file. Okay, one issue I could spot over here is binders. This should not be binders. It should be binder. It's singular. Okay, let me try it again now. So I'm restarting the application. We'll wait for a while, and it should begin producing the message. Okay, so it's producing the message, and if you see over here, okay, you can see a continuous stream of messages now that is being sent to this particular topic. You can see. So there were a couple of misouts that we had from our end over here. Okay, now one thing, if you observe over here, what is happening over here is it is sending a continuous stream of message. Okay, are you requesting a continuous stream of message? You've just written this once, right? But because you're making use of supplier, okay, it is sending in a continuous stream of message. Okay, and this is how Spring Cloud Stream treats a supplier. Okay, so that's this is one thing or one question that everyone might have, whoever is watching this. So whenever you define a supplier based function and you make use of it with Spring Cloud Stream, it is being treated as a stream of continuous messages. Okay, and that is why you're seeing like it's producing the message every second. Okay, you can see over here it's continuously producing the message. So if I select this one over here, let me select this one. So all the values are same, and that is why you are not able to distinguish this, but this is actually scrolling. You can see there is a message being produced every second, and you have the ability to control this as well. Okay, so you can specify the configuration that can give you a better control as to on the frequency. Okay, so if you come over here, just go to application.yaml and just go under bindings over here. Okay, so under binding, okay, here you see polar, and you say fixed delay, something like this, and you can have like 5,000 over here. Okay, 5,000 means here you wish to generate a message every 5 seconds. So I'm restarting the application. So now it was generating every 1 second because that is what the default was. So see, now it's generating. Okay, so now also it's generating every second, 1 second. Let me see what the issue is. Okay, so this polar should be under stream over here. Okay, this should be under stream. So we need to say shift tab so that it comes one level behind. And now let me try running this application. Okay, so I'm restarting the application. Ideally, it should work now. It should be producing one message every 5 seconds. Let's wait. Okay, you can see first message generated. Okay. After 5 seconds, second one. So it's working fine. You can see over here. If I select this, this is one message. Now there'll be one more after 5 seconds. So there is one message that is being sent now every 5 seconds because of this this property that we have added. Okay, the default is 1 second. Okay, and this is basically the property for stream over here. So under stream we have added this. And be sure about the indentation. Okay, you just saw like I did not have the right indentation and this was actually not working. This actually didn't work, right? Now one question you might have is we are making use of Spring Cloud functions over here, right? So this is a function that we are making use of, and we are making use of Spring Cloud function related properties as well. So we are making use of this concept of Spring Cloud function internally. Okay, and if you come to pom.xml, we don't have the dependency added for Spring Cloud function. If you see, okay, Spring Cloud function dependency is commented out. You can see we are not making use of Spring Cloud function dependency. So you will be like, hey, how is this thing of Spring Cloud function actually functioning over here without the dependency? So to explain that to you, the answer to this is Spring Cloud Stream is the answer. So Spring Cloud Stream uses Spring Cloud function internally to turn your functions into event-driven Kafka or any other messaging producers or consumers automatically. Okay, so it does the job of binding the functions to that or connecting these functions to messaging systems like Kafka, RabbitMQ without you writing the low level code. Okay, and you can like imagine like here we have just made changes to like 3 files. This first file is where we have added all the dependency related to stream and binder and then Jackson related dependencies. These 3 dependencies is what we have added. Now starter dependency we have to add in the Spring Boot project so that it should behave like a Spring Boot project, right? But these are the dependencies that are related to our functionality. And then I have created this producer wherein literally I've just defined a supplier. I've not done anything else and I've just created a configuration file. And then in application YAML, I have defined certain configuration for Kafka. Now, if I want to switch over to RabbitMQ tomorrow, what I will do is I'll come over here to producer. Instead of this being Kafka, I'll change this to Rabbit. You can see this Rabbit. This is what I'll change this to. Rest everything remains same. And here I'll come in application YAML and I'll update this from Kafka to RabbitMQ. Okay, so this entire property will change. I'll point to RabbitMQ instead. Right? And rest everything remains same. So this is the power of Spring Cloud Stream, wherein without writing any sort of low level code, you have the ability to produce and consume messages. Now let us replicate this same thing in consumer as well. So in consumer, we should transition this consumer project to that of streams, and we should see how this behaves. So I'll come over here in consumer. First thing is I'll open pom.xml, right? Because here also we need to update the dependencies since we are making use of Spring Cloud Stream. So I'll just add all these dependencies that we have uncommented. I'll come over here in consumer. If you scroll down over here, do I have Spring Cloud being added over here? Let me check. Okay, it seems Spring Cloud is not added itself over here. So I will add under dependencies. I'll add these dependencies first. Okay, of course I'm going to get error if I do a Maven reload. Okay, because Spring Cloud dependencies are not there. And then the rest of the dependencies, I'm going to comment it out. So you can see over here, everything is commented. All right. And you have these dependencies added. Now for adding Spring Cloud, what I will do is I'll scroll down And here I have this tag of dependency management. So I'll just copy this. I'll go to consumer, and just after dependencies, I'll add this. Okay, scroll up, and here you have the Spring Cloud version. So under properties, from under properties, I'll come over here and I'll add this. So why did we add this Spring Cloud version? Because this dependency management is making use of this version over here. Okay. Now, if you do a Maven reload, ideally it should work all fine without any issues. You should not face any issues. Now, within consumer, what I will do is if I come to, Kafka consumer, am I getting any sort of errors? Not really over here. Okay. But this is the old code. Okay. Wherein we are making use of Kafka specific stuff over here. Right. I would like to just comment this out. I've commented this out entirely, and then I'll close this, and then within the same package I'll create Kafka consumer new. Okay, so I'll say Kafka consumer new. So I commented that previous code because I don't want any sort of conflicts or clashes over there, right? So now I've added this consumer. I'll mark this as configuration, or let me not mark this as configuration. Okay, and here I'll directly begin writing a bean over here. I'll say public consumer, like so, and here I'll say rider location, and you'll see process rider location over here, and here you'll see a location, and then here I'm going to make use of system.out.println. I'll say received. Okay, so let me add this in quotes. Okay, double quotes. So this is received, and I'll say plus location dot get rider ID. So let me see. Okay, so I'll add this. Then I'll say at the rate. Okay, so this is the rider location at this latitude, location dot get latitude, and then I'll print in the longitude. Okay, so I'll say plus over here something like this, and then I'll say location dot longitude something, and I'll add a semicolon over here. So this is the consumer that I've added over here in the Kafka consumer new. Okay, I'll just optimize imports and remove unused imports. Okay, and this is the consumer. Now what we need to do is we need to add or update some YAML related configurations as well. So here we do have quite a few configurations. So I'll just comment this everything. Okay, comment everything out. I don't need anything. We'll just start fresh from here. Okay, now over here I'm going to say we need to define the function first. Okay, and so here I'll say Spring Cloud Stream, and then you're going to say function, and I'll say definition. What is the definition? Process rider location. So this is the name of the function. Okay, then over here I'm going to say bindings, and here you will say process rider location in 0. Okay, so here I'm mentioning this, and we are mentioning in over here. Okay, because we are receiving the messages. Okay, so if you see over here for the producer, it was out, right? So this function will process out, and this function over here is accepting it in, right? That is why we have in over here. Okay, so it's all convention over here when you start working with streams. So here I'm specifying destination. Okay, be sure of typo over here, otherwise it won't work. Now you can have my topic new. This is the topic that we are listening to. Okay, and then we need the binders over here for Kafka, and this we need at bind under stream. Okay, so under stream over here. So I'll come over here. Under stream is where I'll paste this. Okay, this is done. We have the server port 8081 setting as well. Now let us test this and let us see if this is working fine. Okay, so I'll start this. Now it is still producing messages. If you see, if you go to the producer, this is producing messages. You can see one every 5 seconds. You can see. So all the messages are same, and that is why it will be tough to distinguish as to when it is producing. So you have to just select this line, and the selection will move forward. which indicates that the messages are being produced. Now here, okay, some issue over here. What is the issue? Is there any sort of issue? It exited. Why did it exit? Let me rebuild the entire project over here. Let me rebuild. Okay. And let me start the consumer again. So sometimes what happened is the project is not built properly, and that could be one reason. Let us see what the issue is. So this is not working, likely because of the configuration annotation which we were adding, but I just purposely removed it. Let us add this and let me see now if it works. Okay, so let me start this. Okay, it should work now, ideally. So yes, it's rejoining the group, and let us wait. Okay, you can see topic has been assigned, and you can see it's receiving the locations now. You can see it's listening to that particular topic. Okay, this is being produced and this is being consumed, right? So you can see, you can select this. It is producing one message every 5 seconds because of the configuration that we have added, and you can see all the messages are being received over here, and we are listening to these messages from command line terminal as well. You can see. Okay, so this is how you can transition to Spring Cloud Stream with the help of like Kafka. Okay, so yeah, I hope this has been useful. If you're enjoying this course so far, then you should also check out our complete full stack development mastery roadmap, the details of which are given in the description below. It comprises of multiple courses that you would have access to. Also, you'll find these details on the website as well. All right, the website is embarkx.com, and I would highly encourage you all to check this out to become a pro developer. So now let us talk about how you can send the messages to different partitions in the same topic. So as you can see over here, okay, not this one, but over here, we already have this Kafka topic config file, which is there in producer. And this is the file that is responsible for defining any sort of topic configurations if we wish to. All right, so we can define a new topic. We can set the number of partitions, and you can set the replication over here. Right. So if you come over here, you can like describe a particular topic. So first of all, you can list the topics this way, like so. Okay. And let's say if I want to describe like my topic new, so I have this command over here, which is Kafka topics describe topic. And instead of new topic, this will be new topic new, something like that. Okay. Is it new topic new? Let me check in our YAML. Okay. So here, if I go to this over here, okay, which is the topic name, my topic new, I'm sorry. So here if you come, now it is my topic new. Okay, like so, my topic new. So you should see like it has 0 partition. Okay, so let me switch over to a topic that has some partition. So here I'll go to my topic. Does this have, okay, so this has 3 partition. You can see this has 3 partition count is 3. Okay, now what I will do is I'll start listening to this particular topic. Okay, so here if you say Kafka consumer topic, my topic new, instead of my topic new, I'll just update this to my topic over here, like so. Bootstrap server localhost 9092 group is my group, and from the beginning. Okay, so I'm specifying it from the beginning. Now over here, I would also want to print the partition. So I'll say property print dot partition is equal to true. So this is one line that I'm adding over here. I'll say enter. Let us see if it's printing the partition as well. Okay, but we need to produce the message at that partition, right? So to see this partition, I will come over here. I'll quickly update this from my topic to that of my topic. Sorry, my topic new to that of my topic over here. So I've updated this to my topic here instead of sending or producing messages for my topic new. And I'll just restart the producer over here. Okay, let me restart the producer. And if you see, the producer is started and it should start producing the message. So you should see, okay. So you can see now, okay, we are seeing like the messages. There are messages being printed, produced, and being printed along with the partition. You can see it over here. Okay, this is how it will be. Okay. So let me zoom in a bit. Okay, now you can see this is how the partition is being printed. So you will observe one thing over here. Okay, what is that one thing? All the messages are going to a single partition, which is partition 0. And why is it happening? Because Kafka uses message key, which is rider123, and it determines the hash. It generates a hash based on the key, and based on the hash, it is sending it to a partition. So since 123, rider123 is always same for all the message, Kafka always hashes it to the same partition, which in our case is partition 0, right? So what we would want to do is we would want to basically send it to different partitions, right? And for that, we'll have to make sure that this key is generated on the fly, right? Rider123. So I'll modify my logic of producing. So if you come over here, we have this producer streams. Here, I'll modify this logic over here. Okay, so instead of having this hard-coded as rider123, what I will do is I'll say string rider ID over here is equal to, I'll say rider, and then I'll make use of random.nextInt. Okay, random.nextInt. So what is random.nextInt? So I will have to create an object of random over here, random, and I'll say random is equal to new random. Okay, and here I'll say random.nextInt, and I'll set a bound of 20 over here. Okay, for example, so it will generate the random numbers between under 20 basically, right? And it will assign it to rider over here. Okay, and I have the rider location and everything set, and over here I'll update this. So I'll update this to rider ID like so. Okay, and I will just take this to the new line. Okay, so now this is looking fine. Okay, and we are also printing the rider ID over here. Okay, and yes, I think this should be it. Let us see if we are able to get it working with this. So I'm restarting the application. Okay, and let me also update this. So instead of having a fixed delay of 5,000, I'll just update this to 1,000 so that we have some quick messages being produced. Okay, so I'll restart this. Okay, and it should be producing messages in no time. So rider 3, 12, 10, you can see over here. And you can see now it's going to different partitions, 2, 1. Okay, earlier it was 0. You can see it was 0, then 2, 1. And it will keep on changing depending on what number is being passed and what value it's being hashed to. So right now you can see for quite some time it's partition 1, but it's no longer going to 0. It's changing the partitions is what I want to tell you over here. Okay, partitions are being updated every now and then, and you can see this in action over here. You can see now some messages were sent to partition 2 here. Now again the partition is changed to 1. Okay, so yeah, this is working fine over here, and this is how you can send messages to different partitions. So now is the time that we begin talking about how can we have multiple topics and produce the messages for different topics. So what I'm going to do is here in the producer, okay, here in the producer, I'm going to add one more producer. Okay, so I'll come over here to this particular file. Here I'll add one more use case. So here what we are doing is we are sending in a rider location to this particular topic that we have configured. Okay, now here we have hard-coded the location, but in real world it could be some application like a front-end application or a mobile app that is sending and calling in this API. I have a supplier over here, right? So this is one use case. Now what I will do is I'll create one more supplier over here, which will be sending in the status updates, for example. Okay, so I'll send in some status updates. So this is sending in location. I'll create one more supplier which will send in status updates. So let me replicate this. Okay, sorry. So I'll just do Control C. I'll come over here, Control V, and here I'll say send rider status. And here I will send, I'll set this return type to that of string over here, like so. Okay, I have random, and here I'll generate a random rider ID, and then instead of rider location, I'll say string status. So string status, and I'll say random dot next boolean. Okay, so I'm generating a random boolean over here. Okay, now based on this boolean, if this is true, I'll say the status is ride started, something like this. Okay, so ride started, and if it is false, I'll say ride completed. Okay, something like this. So I'll say ride completed, like so. Okay, so I'm generating statuses randomly. Okay, and I will say, I'll say sending status over here. So what is the status? Status is this status over here, right? And this is it, what we need. This is what we need. And now what do we return? We will return the status over here. Okay, but we also need to make use of rider ID. So what I will do is I'll change the return type of this to that of message over here, and here, okay, this is message, and here I'll say return message builder. Oops, so sorry, not message dot builder, but it's message builder over here. Dot, I'll say with payload over here, and here I'll say rider ID colon, sorry, plus, I'll say colon, and here I'll say status. So this is what I'm sending in. Okay, like so. Okay, and then I will come over here. I'll say set header over here, and then I'll say Kafka headers. Okay, oops, not Kafka handler, Kafka headers over here, dot key. So this is the key, and I'll say the key is rider dot rider ID dot get bytes. Okay, and then I'll go again over here. Here I'll say set header, something like this, and here I'll say message header dot content type. What is the content type? The content type is MIME type utils dot text plain. Okay, so text plain over here, like so, and then here I'll say dot build, like so. Okay, this is done, and there is still some problem. So I'm saying message string, and does not have any sort of parameters. So this is coming in from Kafka common protocol, and this is, okay, 1 second. So this should ideally be, so I realized one thing here. I have done an import from Kafka common protocol, but it should be from here, org Spring Framework messaging. So I'll update this, and you should see the error going away. Okay, so this is done. Now what I will do is, since I'm sending the message to a different topic, I want to send a message to different topic over here. So I'll come over here, I'll head over to application YAML. Okay, and we will have this message being sent somewhere else, right? So what I will do is, here I'll come, here we have this send rider location out 0, right? So here what we are doing is send rider status, right? This is the method name. So I'll come over here, and here I'll say send rider status hyphen out hyphen 0, something like this. Okay, and here I'll say destination colon my topic new. Okay, and then I can say content type colon text slash plain, like so. Okay, so this is done. Ideally we should be sending in now the messages to different topics. So one is my topic, another one I'm sending it to my topic new. Okay, one is getting the location updates, another one is getting status updates, and we have 2 suppliers for the same. So let me restart the producer application is what I've restarted. Let us see how this behaves. So you can see sending rider 4, rider 7, rider 12. Okay, what is the problem here? So we should be ideally printing the status, but it seems this status is not being printed. Okay, so I understood the issue. So here we have just defined, so here in Spring Cloud function and stream function definition. Okay, so in fact, majorly over here, we have rider location, right? But we don't have send rider status defined over here. So I'll just add a semicolon and send rider status as well. So this is now identified as a Spring Cloud function. Okay, let me see if this works well now. You can see sending completed, rider 3 completed, started. So there are messages being produced, and now if you see over here, you can see the data being produced here. Okay, but we'll open one more console. I've logged into Kafka, and in one more console, I'll listen to my topic new over here, because that is where we are sending in the status updates. So I'll listen over here, and you should see, okay, my topic. Okay, you can see started, completed, started, completed. Let me shut this, and let me also get the what we call it, the partition numbers. Okay, so I'll just get the partition number as well. Okay, and so here, if you see, okay, 1 second. So there has to be, okay, there is a property that we need to add for partition number. Okay, so the property is we need to set over here 2 times hyphen over here, and I'll say property print property, and I'll say print dot partition is equal to true, like so. Okay, and instead of my topic, this will be my topic new. Okay, so this is one change that I'm doing so that I get the partition as well, my topic new, like so. You can see. Okay, so now you can see it's sending in the data, and you can see all the data that is being received. Okay, here also you can see the data being received. Okay, if you see, you'll see everything is going to one partition only. Okay, and let me check. So here I believe we are sending in the data. So if you see, we are sending in the data to my topic new. Okay, so if you come over here, okay, my topic new. So this has only one partition is what I believe. Okay, sorry. So not this command, but I need to run my topic new, right? So here I'll say my topic and then hyphen new, something like this. So this has only one partition, but there is one more topic that I have already created. So if you say new topic, this has probably a couple of partitions. So this has a couple of partitions. What I can do is I can send the message to this topic over here. So instead of my topic new, I can say my or new topic. Sorry, it's new topic. And let me rerun the application, the producer. Okay, and what I will do is I'll listen to this new topic over here. So I'll say here, I'll say new topic. So let me go over here, new, and then I'll say topic. Now let us see if we are getting the data. So you can see the data is being sent and it is being received now on different partitions. You can see partition is changing. It is because of the key, right? So that particular topic earlier, which we were sending to, that had only one partition. So there is no possibility of bifurcation, but this one has multiple partitions. Okay. If you want to create something like, if you want to create a topic on your own, you can make use of this config, which I've already demonstrated, where you can specify the topic name, the number of partitions, and other details. Okay. So I hope it's clear as to how you can add multiple topics and even start seeing the message and send the message to different topics. I hope this has been useful. So right now what we have is we have producers producing and publishing the messages to two different topics over here. Okay, so this is one topic and this is another one. And here, if you come in the producer, we are producing the message and you can see all the configuration over here. Okay, so you have these two suppliers that are sending in the messages to these topics, my topic and new topic. Now let us see how we can consume messages from these two topics via consumer. So I'll head over to consumer. We have all the configurations done except that we need one consumer that will start consuming. So this is one of the consumers who is processing the rider location. Okay. We need to add one more consumer over here, which will process the rider status update. Okay. So what I'm going to do is I'm going to simply replicate this one. I can replicate this one here. Okay. And I will come over here. And then here I'll mention string as the type, like so. Instead of this process rider location, this will be process rider status, something like this. Okay. And instead of location, I'll receive status over here. This is how I'll receive it. And I'll get rid of all of this because this is not an object, but instead a string. And I'm going to say plus status here, something like this. Okay. So this is what I'm doing. And what I will do is I'll add or configure this in the YAML file. So I'll copy this. I'll come over here. And here, okay, so this is the producer. So here I'll go to consumers application YAML. So this YAML file was of producer is what I mean. So here I will come and here I'll add process rider status. I'll say in -0 and then I'll say destination. And here I can specify the topic. Okay. Now from producer, we are sending in the location to my topic and the status to new topic. Okay. So here I'll say the location is coming to my topic and status is coming to new topic, something like this. So make sure you are having the right topic names over here wherever you are sending in. Otherwise this will create an issue. Okay. This is done. Now what I need to do is here I need to add process rider status as I need to define this as a function. Let me run this. Okay, so we are running the consumer now and let us see if this works. Okay, so this exited. Okay, there is no log, but it did not connect. So I guess I know what is happening. Now here, if you go to producer, we have this cloud function definition as well, right? So we need to add that as well. We are not adding that over here. Okay, so here under cloud, I will just paste this. Okay, so I'll paste it over here like so. Okay. And here instead of send rider location and send rider status, I'll have process rider location and process rider status. So this will declare this as these two functions as Spring Cloud function as well. And let me start the consumer. Okay, so you can see it will start consuming now. Okay, you can see now. You can see the rider information and the status related information both are coming in. You can see. Okay, so this is how you can consume the data from multiple topics. All we had to do is just have some sort of configuration and things are working for us. I hope you are able to follow along. Now let us understand how you can consume messages and how does consumption works with consumer groups and without consumer groups. So what I'm going to do is, first of all, I'm going to come over here. Okay, and here in edit configuration, I am going to duplicate this particular configuration. So I'm going to have one more instance of consumer application. Okay, and this instance will run on some other port. Okay, so here I'm going to say in place of program arguments, I'll say -2 times. Okay, server dot port, and I will set this to 9091. Okay, something like that. So just give it a different port number because this will eventually run on a different port number, and I'm overriding the default port number that we have for this application. Now, if I run this, let me see what happens. Let us see what happens. So this is the new instance. You can see it started. Okay, and you can see it started receiving all the details. Okay, and now you can see over here it is listening to 13 12 8 1, and here also it is listening to 13 12 8 1. You can see. Okay, so whatever they both are reading are same. They're reading to the same thing because there is no consumer group. You can see if you switch this very fast, if you switch the output really fast, you will see both the outputs are same. There's literally no difference, right? Why is this happening? Because they are not a part of group, right? You don't have multiple, you do have multiple consumers running, but they are not running in the same group. And when you have multiple consumers running in the same group, Kafka will divide partitions among them and they both will no longer read the same messages. So how do you make that happen over here? So what I can do over here is, let me come over here. Okay. And here I will add a group property. Okay. So what I will do is I will say for the location over here. Okay. Only for the location, just say group is rider location group grp. Okay. And I will come over here. Okay. In the Kafka consumer new. Okay. And I will, okay. I won't edit anything else. I'm just adding this. And then what I will do is I will start both the consumer instances. So this one as well as this one. Both are running now. Okay. So both are running, and let us see if they both are consuming the same messages or different ones. Okay. So now you'll see. Okay. Started. Okay. There is some problem that has happened. Okay. You can see some issue related to offset they both are getting. So let me stop both, stop all. Let me stop the producer as well. Let me start the producer, or let me start one consumer first. Okay. This is one consumer. This is another one. Okay. It's being assigned. Okay. Wait a minute. There is some problem here. Okay, so it's working now. What I did is I just did a rebuild to the entire project because there was some issue. And after rebuilding, I restarted everything like producer and both the consumers. Now you can see, like you are seeing the write started details, like the write status details in both the instance of this consumer is same, because write status is not being consumed in group. Okay, you have not added group over here for write status, like you can see over here. Okay, but for consumer application, if you take a look at the location, it's being consumed only by one consumer. So which is this one. Okay, and it's being consumed by it because it's being sent to only one partition right now. Earlier it was being sent to 0. Okay, so as soon as the partition changes, you will start receiving the write details here as well. Okay, but what I will do is I'll also add this in group over here. So I'll add this. So instead of status, I'll say, instead of location, I'll say rider status group, and I'll then restart both the applications. Let us see how this works. Okay. So both the applications are running on different port, one on 8081 and other is on 9092 something, I believe, right? So you're seeing write started over here, but here you will see write 14 started, 0 completed, and you won't see write 0 completed over here because they both are consuming in the group. Okay. Even this thing is distributed. You can see some rider location updates were sent over here and some rider location updates were sent over here. You can see. Okay. So this is how things are working in group. You can see both the things are being distributed based on. So this first consumer is listening to 2 partitions, and that is why it's getting more rider details like in terms of location update. But this one is listening to only one partition, and that is why it's getting lesser location related updates. Okay. So you'll see for now it's the hash value for the key is being sent to partition 0. Earlier it was 2 and it also switched to 0 in early on basically. Okay. And after a while it will switch to 1 and 2 again, and then we'll again see some sort of distribution over here. But you can see over here for the location updates, you can see it's being distributed properly, right? So I hope this is clear as to how you can consume the information in groups, and I hope this has been useful.